decided at long last to give you the memorandum or the suggested answers of this mathematics N2 question paper after a lot of requests that I was getting from the students who are subscribed online, as well as the ones who are watching our YouTube channel. They've been asking to say, can you please do the mathematics N2 April 2020 paper? But remember, this paper was actually written not in March, April as anticipated, but it was postponed to I think around July. That's when it was written. Remember guys, we had a lockdown during April. Actually, during this time last year we were on lockdown, so these exams were postponed because of the coronavirus. Now, they were written in July, August, somewhere there, but it was still they never changed the paper. And students have been saying, can you please do us that memorandum? And at long last, I've thought of sitting down, getting all the time, and bring you this memorandum. It's actually a suggested solutions or some strategies or concepts that you can use as you prepare for your final exams. Now, I will also do a disclaimer in advance to say there might be errors in these answers. And if you pick up any errors, please don't hesitate to suggest some solutions. Of course, you can criticize, but remember, this is the aim here is to assist and to help. I'm not an expert in maths, but I believe my approach sometimes helps a lot of students in simplifying mathematics. I struggled a lot with this subject. In my early days, it also gave me a nightmare. But because I ended up finding ways of approaching it, I think it has become even better to show to others how I approach this subject. So I thought of bringing it to you. And again, guys, remember to subscribe to our channel, our YouTube channel. And after subscribing, don't forget to share it with others who also need some help. The more you share, the more I am also motivated to see that most of the people are benefiting from these. Because remember, I'm doing it for you. As you see, it always says reaching out is proof of passion. I'm reaching out to you. You also have to reach out to others. The more you help, the more you also get the benefit of that feeling to say, at least I've got the satisfaction that I helped someone out there. So now let's dive into this class or into this lesson. As I said, this paper was written in by the way, my name is Confident. Welcome to our session of the memorandum discussion of the mathematics N2 paper. Someone is asking, who is this guy? It's Confident. My name is Confident. Alright, so this is a national certificate, and here is mathematics N2, and of course you have, this is the date, but it's not the actual date. When they say X paper, it means it was written in the morning. It's a 3-hour paper from 9 up until 12 o'clock in the morning. Now it says requirements. You need 2 sheets of graph paper. Then they state the graph paper, but I don't think I'll be able to use these graph papers. I'll also just give you a demonstration of what you can do whenever those questions are involved. Then it says calculators may be used. Now let me show you the calculator that I'm using. I'm using a Casio. This is the 82AS, so that's the one I'm using, but I would encourage you to use the FX82ZA Plus because it allows you to do more functions such as plotting 2 graphs at the same time. But this is a perfect one. If you have it, if you have this or something similar, this is perfect. We also have some that we are selling in our office, so we can also sell you something similar to this. Not identical, but it's also like similar. Alright, so this question paper consists of 7 pages and a formula sheet and 2 pages. Remember to always consult your formula sheet wherever it is needed. So let us look at a few things here before we begin our discussion. It's small things that students sometimes take for granted and they forget some of these instructions, especially the instructions and information. So we say it is 3 hours. Remember to pace yourself. Now it's out of 100 marks. So that is the mark allocation of this paper. And then says instructions and information. Don't always jump this section because it is very important. It says answer all the questions, read all the questions carefully, number the answers according to the numbering system used in this question paper. So don't come with your own numbering because they'll penalize your mark. Then it says, show all the intermediate steps and simplify where possible. So sometimes it's always tempting to write your answers first in the question paper as your rough work, but remember to take all those workings into your actual answer book, because if you don't do that, you won't be marked for whatever you didn't write in the answer book. So remember, in as much as you are working in your rough work, doing your rough work in your question paper there, don't leave that rough work there. You need to take those steps into your answer book. And then says, use black, blue or black ink. Avoid using coloring pens. This is an exam, guys. You don't have to make your work beautiful. So you find some are now doing, you like to make your work neat. So you are underlining after writing with the blue. Sometimes you change, you put your red on this. You're making it lovely and nice. This is unnecessary. It's not in a way like an art kind of thing that you're doing. You're doing maths. So you just need to use blue or black ink. If you're going to use a pencil, they will not mark that work. Remember that. If you're going to use a pencil, they will think it's rough work. So you can use it for your drawings, but whenever you are writing, use blue or black ink. You can even use your blue or black even when you're drawing the diagrams. Says write neatly and legible. This is very important, guys. Neat work is very important. How you number your work, how you arrange your work is very important. Now, I've seen these days something interesting that you find there's some ink, some blue or black ink that you can erase. So you can actually use it even when drawing your graph. If you make an error, bring that pen that you can also erase. It's got this special rubber or eraser that you can use. So it's also a good one. Alright, now let's dive into our lesson. Obviously, we're starting with question number 1. Now, some of them I'll be working them directly from this paper. Sometimes I know it's too bright. Some it affects their eyes, but I will try to also bring in a black screen where it's needed. So whenever there's a lot of writing, I'll try, and simple steps, I'll try to use just what I'm having here. So look at this question. It says, question 1.1, it says simplify the following without using a calculator. So in this case, you must not use a calculator, but what I advise my students is whenever they say don't use a calculator, it is when you take the calculator where possible and use it so that you can find the answer, then work towards that answer. I hope you get what I'm saying. So in this case, 1.1, let us start our question. So this is 1.1, it's 1 mark. So how will I approach that? Let me make this a little bit bigger. So when they say I need to simplify, remember, simplify without. So when I look at this, it's 1 mark. The main thing that they just makes me not to do a lot of things there is that this is to the power of 0. For example, if I just do this with my calculator and say, put a bracket and say 9, close the bracket, and then say to the power of 0. You see, I'll just get 1. I can change any number inside here and just any number, see how many numbers I'm using, as many numbers as I can, as long it is to the power of 0. If I say equal to, it will give me a 1. So the answer there was simply a 1. Just think of it. So any number or anything to the power of 0 is a 1. And if you check, this power of 0 is affecting everything inside the brackets. So when they put it like this, it means everything is to the power of 0 that is inside there. So it will then equate to 1. That's why you don't have to think much about that. Now, anything to the power of 0 is a 1. The next one, it's log base square root of x of x. Again, let me show you my calculator. I think this question also was 1 mark. Before I show you that, let me just, yes, it's 1 mark. So we are now looking at, done there, we're here now. I think it was 1 mark. Now look at the calculator here. If I say, for example, log, I say square root of 2, and then I say square root of 2. If I maintain the base like that, they say square root of x, square root of x. So my x here is like square root is 2. So square root of 2, square root of 2. You see, I'm getting a 1. I can change any number. Maybe here, put whatever 698, but when I put 698, even down on the base I put 698, the answer will always be a 1. So even here, when you say square root of x, the answer is equal to 1. What's the reason behind? When the base and the number are the same, then you get a 1. So those are just your appetizers. You know, you're getting the appetite to do more as you're getting motivated. You're getting the, what you call this, you're getting the momentum. You know, these are the simple questions that you feel like, at least as I'm beginning my exam, I feel a little bit of energy. Don't overthink it, because it will exhaust your mental energy. Whatever is simple, just simplify and move on. Next question, 1.1.3. We are supposed to simplify this. Now, let me see how many marks this was. It is worth 3 marks. You can see that. So which means there's a little bit of working. Now, if I bring my screen back so that you can see better. Now, we are given quite a few things here, but how do I approach this? You see, this question, you mustn't approach it as a whole like this. It will confuse you. What you can do is just do it in parts. For example, I'm going to take the inside, this inside, right? So when I take that inside, the first thing I'll have is cube root, because it's a 3 there. I'm just taking that one and deal with it for now. P30, or P to the power 30, sorry, Q to the power 36. That's what I'll be saying if I'm saying Q36 in a way. Though I know it's wrong, but anyway, that's it. So I've got that. Now with this that I'm given, this cube root is the same as saying I put a bracket and that cube becomes over 3. It's power. It's not over 3. It's a power. Now that power, the denominator of the power is 3, but because here, if you do this, because it affects everything, there will be a default 1 there. So you say 1 over 3, because everything is under that influence of the square root. So you put the 64, the P to the power of 30, and the Q to the power of 36. Now when you've done that, what you can do, remember, okay, let's deal with 64. I forgot to deal with this 64. This 64, you can deal with it much quicker. You use your calculator to say, why did they give me 64? You need to know such numbers like 2, 8, 16, 36, 64. For example, if you say 2 to the power of 5, you see, it's 32, and then 2 to the power of 6, it's 64. So you can see that this is actually 2 to the exponent 6. Now you need to then use the laws of exponents to say when you have a power on the outside, this particular power will multiply the powers on the inside. So you distribute it, but on the powers. So what you're going to have is, you're going to have 2 6 times 1 over 3, then P30 times 1 over 3. You see, I'm distributing that 1 over 3 exponent there, and then Q36 times 1 over 3. That is the laws of exponents. Now again, I've got all the lessons. That's why we've got online classes. I've got all the lessons that are already pre-recorded that you can enroll for you to learn everything you need to know about your maths N2. So if you're interested, check our website. At the end of this lesson, you can check our website www.24minute.co.za. You can get how you can get more resources on that. But there is a lot of information so that when you come to this stage, you won't even think twice about it. You'll know the answer in a very simplified way. Alright, moving on. Now you multiply 6 times 1 over 3. The 6 there gives you a 2. So this is 2 squared. The 3 into 30 is 10. So we have P exponent 10. And then the 3 into 36 is 12. Then we've got Q 12. So that is what we were having on the inside of that. But now we move on. As I said, you do it in parts. So you've got that. Then that was our first part there. Then we move on to say, but they gave us the outside square root. Look at that outside square root, that one. Now that square root, what it means that when you are writing, so we'll be having this square root now, which is 2 squared P10 and Q12. This square root, similarly like the 3 there, you do this. Now, because if they don't write any number there, the default there is 2. That's why they call it a square root. So again, it's more like you're having a bracket, because you're having a bracket inside because it's under the influence of the square root, and you've got 1, so it will be 1 over 2. Then you've got your 2 squared P10, P to the power of 10, and Q exponent 12. Similarly, you open that again, the half multiplies the half, it's only multiplying the exponents, okay? So when you've done that, it will be 2 to the power 2 times a half, P to the power 10 times a half, and Q to the power of 12 times a half. Then when you simplify it, you cancel there, you'll have 2 to the power 1, P to the power 5, 10 divided by that. You can use a calculator there. Always use your calculator. Q to the power of 12. I always emphasize, 6. I always emphasize to my students, you need to rely on your calculator. Please don't use your mental. I don't want to think a lot and exhaust yourself. So just go to your calculator when you're doing the simplifications. Now we have done that. We are simplifying well. Now what do? We have done the top part now. We're covered with the top side, and the whole top side has simplified to that. Which means now this then becomes 2, 1, P5, Q6 divided by 2, P minus 2, and Q minus 5. You see how it's like. When you do that, the 2 cancels the 2. So far so good. Then you have to use the laws of exponents. You see, we have got negative exponents at the bottom. Now, there is this law which says when you've got 1 over a to the power negative m. Now, if I want to take this to the top, the a will change, the power will change from negative to positive, it will become positive m. So that's what you're doing. But if I had 1 over a to the power m, since I have got a positive, if I take it to the top, it will be a to the power negative m. So it's a matter of interchanging the signs. When it's positive, it becomes negative when it goes on top, like that. So now, which means the p to the power of negative 2, when it goes to the top, it will become positive 2. The negative 5, when it goes to the top, it will become positive 5. So what I'm going to be having then, I will have P5 and Q6. Now going to the top, I have got now, start with the P, I've got the P2 and Q5. You see that? Then if I bring it all together, collecting like terms, it's more, I've got P5 dot P2 and dot Q6 dot Q5. Even if there was no dot, it means they are multiplying. Now here, when I've got P, 5 and 2, when they are multiplying, they are 5 plus 2. And then Q, 6 and 5, it's 6 plus 5. Then the final answer to that will be P7 and Q11, because 6 plus 5 is 11. This becomes the final answer for that. Now what I usually do, I test my answers. I always prefer to test my answers. For example, how do I test my answers? I choose any value. For example, I will say let my P be equal to 2 and my Q be equal to 3. So I'm going to take a calculator. Wherever I see my P, that P to the power 7, it will be 2 to the power of 7 times Q to the power of 11 will be 3 to the power of 11. It will be a big number. Don't know whether I'll be able to see. It's 22, 67, 48, 16. 22, 67, 48, 16. 22, 67, 48, 16. It's just this big number. Now, I want to go back to the top and do the same thing. Where there is my P, I do put a 2. Remember we said P is 2. here. My P is 2, my Q is 3. So I'm just going to do that and see if I'm getting that answer that I got below. If it must give me the same answer. So I've got square root and I've got shift. Where is that square root to the shift? Cube root. It's down there. There is the cube root. So I've got 64 here times, remember my P is 2 to the power of 30, big number there, times Q is 3 to the power of 36, that's very big also. Alright, then play down, it must be over 2 times P, which is 2 to the power of negative 2, right, times Q, which is 3 to the power of negative 5. See, when I do that, equal to is 22, 67, 48, 16. 22, 67, 48, 16. 22, 67, 48, 16. You can see that it maintains the same answer I got. It means my simplification of that is correct. So that's what I use when I'm trying to test. I hope this is benefiting you guys, and you are actually you're going to use these strategies as you go on to your maths. All right, let's look at the next one. So that was 3 marks. I know I take long, but remember this is for the underdogs. So I'm focusing on that learner who says, you know what, you don't need to be too fast. I just want to make sure that I get this thing right. And when I get it right, I'll never forget it again. So it's not just for someone who says, I'm more faster, I need something quick. Unfortunately, my focus whenever I'm doing this is for those who are struggling with this subject. Alright, now 1,14, we're here now. Remember, 3 marks, what did they say? Simplify with the following without a calculator. So this one is only numbers, which means I can use my calculator here. Even as much they said I mustn't, but I need to know when I use a calculator what it will become. So it's log 9. It automatically opens. You see, your calculator opens a bracket. Please close it, because if you don't, you're going to say log 9 minus log, and then you've got 4. So you see, this is now inside the log 9 because the calculator never closed. So you need to come back here and close that bracket. Very important. When the calculator opens its own, you need to close it again. So that is where errors also occur. Log 81, the calculator opened, you close the bracket, minus log 16. The calculator is opening, you close the bracket. What are you getting? 1 over 2. I'll write it on the other side. The answer here is 1 over 2. Now I need to prove how the calculator got that. What do I do? Just study it well. We have got log 9 here. We have got 4 here. See, when you do lessons with me, you'll already see what is happening here. Now, what is it that I'm saying? The 9 and the 8 one is related, and the 4 and the 16 are related. I hope you're already picking that up. What is 81? 81 is 9 squared. What is 16? 16 is 4 squared. So you see what I'm talking about? So you'll have here log 9 minus log 4 over log, again to test what I'm saying is correct. Now if you say 9 squared, you see it's 81, and 4 squared is 16. So I will have log 9 squared minus log 4 squared. So the aim was to match the top and the bottom there. When I've done that, I'm going to use this law. It's a laws of logarithms, which says if you're given log a to the power of m, then this particular m, you drop it down, it will become m log a. You see that law? So that's what we're going to apply. So in this case, if I've got here log 9 minus log 4 over, because of the power, applying the law, this 2 will drop before the log, and this 2 will drop before the log. So it will become 2 log 9 minus 2 log 4. Are you seeing that? Then further doing that, something is interesting. At the bottom, I can take out factorize 2. So I'll have log 9 minus log 4 over, take out 2 because 2 is common. When you take out factorizing 2, you'll have 2 into 2 log 9. You'll only have log 9 remaining here, and then there you'll only have log 4 remaining. You see that? So when you have done that, you are able now to look at what is inside the brackets. You can see that it is similar. In other ways, I mean, log 9 minus log 4 will cancel, and that will cancel. Now, avoid this because it's wrong. Don't cancel it like that. Don't cancel it like that. You are going to get it wrong. That's not how you cancel it, because it goes together as a single thing. The log 9 minus log 4 is cancelling the log 9 minus log 4. Then on top, if you cancel log 9 minus log 4, you get 1. At the bottom, you get 1. So you have got 1 over 2 times 1, which is 1 over 2. That's the answer that they got with the calculator there. So that is how you can simply approach that. And this one just can be simplified. It wasn't much of a challenge. Guys, I cannot overemphasize, if you need classes with me, I'm available for you. You just need to enroll. Of course, it's not for free, unfortunately, because we have to dedicate some time and resources. But just feel free to check our website and information to get that. Now, let's look at question 1.2. It says, solve for x in the following equations. So now we're dealing with equations, and we've got 1.2.1. Now, let me work this on a black screen just to ease some too much white space here. Let me work it on a black space. So it's 16 to the power x plus 2. So I will have here 16, if I can just move that line. So what do I have? I have 16 here to the power x plus 2 over, let me just check again, over 64 to the power 2x plus 1. So 64 to the power 2x plus 1, right? And then this is equal to 256. It is equal to 256. Alright, so the question is, we need to solve for x. As I said, it gives you 4 marks. These are good 4 marks not to lose. And what is this section on? Exponents. The main section here is exponential equations that you are dealing with here. But now, what is what? There are 2 ways of approaching it. But now let me show you how I will have approached it first. First, I have to see, can I express everything in terms of 16? For example, if I say 16 squared, you see, it's 256. Alright, so 16 is fine, but 64, unfortunately, I cannot express, 64 will be difficult. Now, let's try 4. If I say 4 squared, because I want to bring everything in the same base. 4 squared will do, it will give me 16, and then 4 to the power of 3, see that it will give me 64, and 4 to the power of 4, it will give me 256. So you see how I use a calculator? If you want, you could have chosen 2. You're going to say 2 to the power of 4, I think first one. You see it's 16, 2 to the power of 6 is 64, 2 to the power of 8 is 256. So whatever one, whether 2 or 4, was going to be fine in any case. So let me use 4 because it's much a bigger number. So I'm going to have here 4 to the power, let me take my pen there, I'll have 4 to the power of 2, that is 4 squared. Now you can do it like this, and then you've got x plus 2. This is correct, this is fine, nothing is wrong, but it is more easier for you to do it actually like this. You've got 4 squared, then you do that, a small bracket to say this bracket, the power is affecting that. This is much easier for the next stage that you'll be going to. And then over, again, we say it is 4 to the power of 3, and then you have 2x plus 1 is equal to 256. Okay, for the benefit of the doubt, let me leave it like that. I think, can I leave it? Can I leave it? No. Let me change it into 4. We said it was 4 to the power of 4, I think. 4 to the power of 4. Yes, so let me just change it, everything like that. Alright, see, the aim is to change everything in the same base. So the examiner always gives you a hint. They'll give you numbers that are always having a certain pattern. So they don't just give numbers at random, they are giving you numbers that have got somehow a certain pattern. Alright, so now having gotten that, what do I do? Let me take this one to the top. Now, I think I showed you previously to say if I have got 1 over a to the power of m and I want to take it to the top, the m here was positive as an exponent, but when it goes to the top, it will become a to the power negative m. You see that when I remove the fraction, it becomes negative. So using the same concept, I will have now 4 2 into x plus 2. See that? Then times, because it must multiply when it's going to the top, and then it's 4. Now the positive 3 there will become minus 3 2x plus 1. See what I'm doing? Is equal to 4 to the power of 4. So I've managed to make everything flat. I've removed the fraction. So that was the main part there. Once I have achieved that, then things become much easier for me. Now, how do they become much easier? Same basis here, meaning I can add the exponents. So what I'll be having then will be, if the bases are the same, I will have 4, and then I've got 2x plus 2. I can actually open that bracket, but let me wait a bit. So it's 2x plus 2 plus minus 3. You see, I've got plus minus, but what you can do is the negative there, when there is a positive and a negative together, the negative is more powerful. So let me just leave it there, and then it will become 2x actually, it's 2x plus 1. Alright, then is equal to 4 to the power of 4. Again, I'm using the rules for exponential equations. Now the rule says if you have got a to the power of m is equal to a to the power of n. See, the base is the same, then you equate the exponents. Therefore, m is equal to n. That's what it means. So I can use the same rule there on top there to say 4 and 4 is matching. Therefore, the top, the exponents, 2x plus 2, but now it's numbers. Then remember the positive and negative, the negative is powerful, minus 3 into 2x plus 1 is equal to that exponent. So that is equal to that is equal to 4. So that is basically what it was all about. Now let's solve for x there. When you're solving for x, open the bracket. So you'll have 2x plus 2 plus 4. See the calculator importance. Always use a calculator, guys. Now minus 3 times 2. Use a calculator to get your negative 6. Minus 3 times 2. Avoid thinking too much to waste your mental strength. So it's minus 6x minus 3 times 1 is negative 3 is equal to 4. Collect like terms on one side, the x, 2x minus 6x, and then the other side you will have what? 4 already. Then the other 4 will cross, this 4 will come this side, is positive, it will become negative 4. Then the 3 also will jump, negative will become positive 3. I hope you see what I'm doing there. Then 2x minus 6x is more like you're saying 2 minus 6. It will give you negative 4. So you have got minus 4x is equal to 4 minus 4 plus 3. Use a calculator, avoid thinking much, just let the calculator do the work for you. You don't have to overthink things so that you don't make errors. You see, 4 that cancels, you get a 3. Over negative 4 over negative 4. When you cancel that, then it gives our x as negative 3 over 4. So this is the answer that we are getting for the value of x. So x is equal to negative 3 over 4. Now, how do I become satisfied that this answer is correct? Let me go to the original. X is equal to negative, remember, x is equal to negative 3 over 4. That's what we got from our answer. So if I come here in the original and use my calculator to prove if my answer is correct. So what I'm going to do, wherever there is x, I'll put negative 3 over 4. So I've got fraction 16 to the power of, I've got negative, my x there is 3 over 4. You see, it says x plus 2. So this will be plus 2. You need to know how to use a calculator, guys. And then at the bottom is 64 to the power 2x. So it's 2 bracket negative 3 over 4. As I say, you need to know how to use that calculator. And then it says plus 1. So when I do that, I must get 256. If I do that, you see exactly I'm getting 256. Therefore, it means this answer that I just did is correct. That's how I do it. Alright, guys. Remember, this was 4 marks. So I think it was good 4 marks for you to play around. Alright, now let's look at the next one. I'm looking now at 1.2.2 and we're looking at this 3 marks. And 3 marks is also good. Look at this question. This question is also involving logs. And by the way, just to come back to the top question, there are a lot of ways of doing it. Remember, I mentioned putting everything in terms of 2, 2, and 2. So there were many different ways you could have approached this. So I just thought of that one as one for the sake of the time and everything. Now look at this one. Now it says half log 7 1 over 49 is equal to x. So you must always study the question and ask yourself, what is the examiner trying to get from me? They don't just give numbers. Whatever they give always have somehow a relationship. Now if you look at this base and look at 49, you will see that the two are related, because if I take a calculator and say 7 squared, see, 7 squared is 49, you see. So there must always be a relationship somewhere. So I can rewrite this and say this is same as in here to say it's 1 over 2 log 7, right? 1 over 7 squared. You see that? Now I've been talking about this rule of taking 7 to the top. That's what I'm going to do now. I'm going to take it to the top. Remember, this is equal to x. So it will be 1 over 2 log in base 7. Then I'm taking 7 to the top now. It is positive 2, it will be negative 2. This is equal to x. Are you seeing that? Now, remember the law which says when you have got log a, don't worry with the base, but log a to the power of m, when the m is an exponent, it drops down there. So that's what we're going to do. But now you must see how it drops down. When you drop down, you'll have 1 over 2. So you don't just drop this negative 2 just to come there and it becomes just minus 2 like that. And then you write log 7. You don't do that. When it comes this side, it always multiplies. So it's always good to put a bracket or a multiplication sign. That's what it does. Alright, then this is equal to x. Now if you multiply half times negative 2, you'll get a negative 1 there. But as I say, they say do as I say, not as I do. But let me keep on using the calculator. Minus 1 there. So it's minus 1 log 7 of 7 is equal to x. Well, like in the first question, which gave us square root of x, remember, same base, same number, this is 1. So it's negative, there was a 1 there, negative 1 log 7 base 7 is 1 is equal to x. Therefore, x is minus 1 times 1 is negative 1. So that answer there is negative 1. You can actually use your calculator there to check, because if you say 1 over 2, see, the whole of question 1 we've been testing. Then we've got that log 7 and fraction 1 over 49. It must give us minus 1. You see? So you can literally do almost all the questions of question 1 testing to see if you were doing you're getting the right answer across. So you don't have to hope and pray that you're doing the right thing. You can actually have the assurance that your answers were correct. So this is done. 15 marks in your pocket. Ka-ching, ka-ching. Now you're moving on. You just like when you're doing your savings, you know that this one is done. I'm already 15 marks positive. Now question 2. It says given the following algebraic expressions. So in question 2, then it says they give you that one, they give you that one, there are 4 of them. It says fully factorize each expression. You see, that was like a little bit of work there, but let me just do this on my next screen there. So if they say factorize each expression, let's look at each expression. The first one is a squared minus 6ab plus 9b squared. So we have got here a squared minus 6ab and it's plus 9b squared. See, I'm not going to go through the process of factorizing, the one that I do in detail when I do the product sum, because I do a lot of factorizing using product sum where I show you how to factorize such problems. But listen guys, you have to grab hold of my resources. And again, by the way, I also have a mathematics N2 textbook for the underdogs that covers this in detail. You will see the resources as the lesson continues. Now I've got a squared minus 6ab plus 9b squared. How do I solve this? This one, my product here, quickly, my p is positive 9ab squared, 9 squared b squared, and my sum is minus 6ab. This is the simplest way of factorizing. Now my factors are the factors of the product of 9, which is 1 times 9, and I've got 3 times 3, and I think it is the one that is going to work for me. Now the 3 and 3, you can see now if I've got 3ab and 3ab is the one that is going to work for me. Now the signs, if I say minus 3, that is the one actually that I'm looking for. So when I simplify this, it will become a squared. Now instead of 6ab, I'll have minus 3ab minus 3ab. That's minus 3ab minus 3ab. If I take a calculator and say minus 3 minus 3, minus 3 minus 3, you see it's minus 6, so I didn't change anything, plus 9b squared. It's a method. It's good to grab hold of it. Now first one, look at the first two, look at the last two. What's common in the first two? A is common, so a into a squared is a minus a into 3b is 3b. I must get a similar bracket here. I must get a similar bracket, but what am I taking out? I'm taking out minus is 3 and 9 is 3, and then ab squared, ab and b squared is a b. So minus 3b into minus 3ab, I'm getting an a, minus and the positive will become negative. 3 into 9 is 3, b into b squared is a b. So you see what I meant when I say the brackets will always be the same. So when you do that, you simply get in the brackets is a minus 3b, and then you have got a minus 3b, which is good. Some could have recognized this, but anyway, I did not recognize that it was working to be like that. So we've done the first one. The question was factorize each of them. Now let's look at the second one. We're factorizing now. It's a squared minus 9b squared. It's a good one, this one. I like it. A squared minus 9b squared. Now you need to recognize the 9 there, that if you are seeing 2 of them, it means difference of 2 squares. If there are 3, 1, 2, 3, factorizing, product sum. If there are 2, difference of 2 squares. So a squared minus 3 squared b squared. So whenever you're doing difference of 2 squares, remember you open your 2 brackets like this. Now I always say to students, whenever you're doing this one, pretend that you don't see this squared. Pretend you don't see that, pretend you don't see that, and pretend you don't see that. Now what you are seeing is a minus 3b. That's what you write in the first bracket. So of course it will be there. So you write what I was showing you, a minus 3b. In the other one, a, you oppose the signs, is plus 3b. This is the concept of the difference of two squares. Guys, so far so good, I hope. Now look at the next one, a squared minus 3ab. That's the next one, a squared minus 3ab. It's also an interesting one, a squared minus 3ab. There are two of them. It's a difference of two squares. This time, no, because the others cannot be expressed as a square. Like this second part cannot be expressed as a square. If you look at the second one, this was a square, this was a square, this was a square. Hence, it was a difference of two squares. But this other one, 3ab, cannot be expressed as a square, meaning I need just to factorize there. Now, what is common in a squared minus 3ab? A is common. A into a squared, it's a minus 3b. You see that? That's done. Nothing else you need to do there. And then you look at the last one. The last one says here 3a squared minus 6ab minus 9b squared. So if you look at that, it's 3a squared minus 6ab, and then it says minus 9b squared. Alright, we have to factorize this. It's always better to do your product sum, or you can recognize that you have 3 there, 3 there, and 3 there. So if you take out that 3, it's actually can make things simpler for you. But in this case, I'm going to ignore, let me ignore that 3 and just focus on the product sum. But it's something that I wanted you to note, that you can actually take out that 3 there. So my product is that, which is my P there, is 9 times this. So 9 times minus 9 times 3. So 3 times negative 9 is negative 27. So I've got minus 27 a squared, b squared. And then the sum is the center there, which is negative 6ab. And the factors is the factors of 27, which is the product. And I've got 1 times 27, which I don't think will do. And then for 27 again, I've got 3 times 9. And I think that's it. So when I'm writing this one, you see 3 times 9 will give me 27. And for me to get a negative 27, the 9 must be negative and the 3 must be positive. So when I write it, this is how I'm going to write it in there. As I said, I'm doing this so quick because it's a revision session, but not more of a lesson like you are learning everything from scratch. So it's 3a squared. Now it's plus, remember, 3ab minus 9ab. If you say 3 minus 9, you get that negative 6. Then minus 9b squared. Then you check your first 2, factorize it. Check your last 2, factorize it. The 2 brackets must be the same. So in the first 2 is 3 is common there, 3 and 3, and a. So I've got 3a. It's dividing into 3a squared. You've got your a. 3a into 3ab. B will remain. You must get a similar bracket. Take out the negative, as you see, negative, negative. Now 9 is also common, and b. Now 9b into 9ab, it's a there. 9b into 9b squared is positive b, because we took out the negative out. When you've done that, which is the bracket is a plus b and 3a minus 9b. Now you needed further to remember, I said at first 3 is common, 3 was common, 3 was common. You can see that you can further factorize 3 and 9 there to say, but when you take it out, put it there outside like that. So you've got 3a plus b, then you go there, say 3 into 3a is a minus 3 into 9 is 3b. You see that? That is now the finalized version of that. So now the question was fully factorize each expression. Think of it. Just to get this 2.1, it was mainly difference of two squares and product sum is a very 8 good marks. Then the next one is again 4 marks, which is adding even more bonus to this. It says determine 2.1.2, determine the LCM, which is the lowest common multiple of all the 4 expressions. They want the LCM. Now for you to do the LCM here, just want to show you this. If we are going to do the LCM here of all these 4 expressions, what you need to remember, the LCM must have each and every item represented in its factorized form, and then you take the highest powers. For example, let's start with the first one. I've got this part, so I'm going to write it as is. I've got bracket a minus 3b. Now you see it's 2 of them now, which means I need to recognize that this is a minus 3b, because it's twice, it's squared. You see now? You see that? So, but for now, I'm not going to focus on the squared, but I have covered that there is a minus 3b. It's covered. I look for the second one. There is a minus 3b, which is also covered. Then there is a plus 3b. So I go on to say, now I must write the new one. You write everything that is new, a plus 3b. So it's done. Then I move on to the next one, which is this one here. I've got a, so you come back and write your a, then a minus 3b is already covered there. And then I go down to the one that we just did. I have got a 3, again write your 3, then I've got a plus b, which is new, a plus b, and then I've got a minus 3b, which is also covered there. So when I've done this, what I need to do is to write them in the right format, and I also look for the highest powers in each one of them. Now you saw that a minus 3b, there was a higher power there, which was 2. So the answer will become, let's do the right things already. You see you have got the a and 3, so it's 3a, it starts first. Then you have got a minus 3b, the highest power was 2. Then you had a plus 3b, and then you had a plus b. There was no other one which had a squared, so it was only that this becomes the LCM. Now, usually they also ask find the highest common factor, but get hold of the lessons that I do so that you can see how can you find the HCF of the similar things there. Alright, I'm not going to go into that because the question did not require. Some of you are asking, why are you not showing us the HCF? Because the question did not require so. But anyway, for the benefit of the doubt, if they say HCF, you just look at, on all these, look at the one that is repeating in all the 4. So you see there is a minus 3b, you've got a minus 3b, you've got a minus 3b, you've got a minus 3b. So you write it a minus 3b, right? Look at the other one that is also doing the same, repeating like that. You'll discover there is none. Then you take the smallest power, which is just a minus 3b, to the power 1, because these are power 1. Anyway, I said I was not supposed to show you this because it's not part of the question. Alright guys, so this is 12 marks in total, and this was a big bonus for me. If it was something that I was supposed to be clear of in terms of this paper, it was these marks that they gave there. I think they overgave here. So the working, of course, quite working, but it was more like routine. There is no much thinking involved. It's just a matter of applying the already knowledge that you know. Alright, now let us look at 2.2. Now in question 2.2, say simplify the following algebraic fractions. So now this is a fraction that we have to simplify, and it's, as I say, it's question 2.2, and we're here in 2.2.1. Again, what knowledge is required is factorizing, just like we did in the previous question. So the whole is now plus 12. 12 plus 4, 16 marks. The whole 16 marks was based just on that. And actually, I'll prove to you that even the next 24 marks, which is 20 marks, was just testing your factorization. So now let us look at this factorization here. The first factorization here they wanted was this 5x squared plus 6x minus 8. They wanted you to factorize this, and remember, I do my product there. This is my product. 5 times 8 is 40. If I'm not sure, 5 times negative 8 is negative 40. So that is that. So I've got my P as negative 40 x squared. My sum is positive 6x. And then the factors are the factors of the product, which are the factors of 40. 1 and 40 will not do. 2 and 20 will not do. 3 will not do. 4 and 10, let me stop there. It will do the way I see it. Let me see, 4 and 10, I can get a 6 from that. Alright, so I will take 4 and 10 because it will be 10 minus 4 is 6. So that is that, 4 and 10. So you don't need to go further. You just stop there after finding a factor, and then I have 5x squared. It's plus 10x minus 4x. That gives me my 6x minus 8. So equal to, what's common in the first is 5x is common. 5x into 5x squared is x. 5x into 10x is 2. Then minus 4. 4 into that is x. 4 into 8 is positive 2. So you see the brackets are the same there. I've got x plus 2, and then I've got 5x minus 4. Alright, you see that? Next one that they're giving there is 50x squared is that one there, which is 50x squared minus 32, so this is a good one. It's 2 of them. Now when it's 2 of them like this, you ask yourself, what is common? I can only see 50 and 32. I can factorize there, but when you see the square there, be careful, it might be a difference of 2 squares. Now what is common in 50 and 32? It's 2. Let me take 2 out. Now 2 into 50 is 25x squared. Now 2 into 32, it's 16, so it's minus 16. So you see, this is now a difference of 2 squares because you've got the 2. Now look at this. Now 25 is 5 squared x squared minus 16 is 4 squared. So if you can express everything as a difference of, as a square, it means it is now a difference of 2 squares. As I said, how do you solve it? So the trick there was, can you see that 25 is 5 squared? Can you see that you need to take 2 first? If you didn't see that you need to take 2, then it's not gonna go to 25 and 16. So now you just remove those squares, come up with 2 brackets, and you write in those brackets, so you'll have your 2 brackets like this, and you write 5x minus 4 blah 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 blah. So that is what we are doing there. Now let me take everything back. So I've got 5x minus 4 and 5x. Now I do the opposite sign, it's plus 4. It's a difference of 2 squares. Having done that, another one that needs simplifying, you can see, is 3x plus 6. So if I do that one, I've got 3x plus 6. Now it's not difficult, this one. 3 is common there. 3 into x is x, 3 into 6 is 2. See that one? And also the one at the bottom here, as you can see, it is 3x squared minus 12. So if I can say it's 3x squared minus 12 here, 3x squared minus 12, I feel this is similar to what I just did here. You ask yourself, it's just a square and the number, the only number common there is 3, so it will be x squared. 3 into 12 is negative 4. Do you see that it's also coming out as a difference of 2 squares? 3 is x squared and 4 is minus 2 squared. Are you seeing that? Then what are you going to be having? You're going to have 3, you open 2 brackets like we did previously. Then you have got x minus 2. The other one is the opposite sign, it's x plus 2. So guys, this is how all these were simplifying. There is nothing more that can be simplified from this. This is what we are having. Now your aim, that's why I was not writing directly there. So the aim now is to take everything into this. So this will be equal to, you write it in factorized form, it's my x plus 2. But you remember, you need to show all this working. 5x minus 4 over the 3x, there is 3x plus 2. Now I have got divided by, let me still write it like that, then that will be 2 into 5x minus 4, and then 5x plus 4 over, then that one becomes 3 into x minus 2 and x plus 2. Alright guys, then we have the last one, which is times 2 over x minus 2. Alright, so let's simplify it further. Now what I need to do, I prefer cancelling everything at once, but I need to deal with this division sign. It must change into a multiplication, please. Then when it changes to a multiplication, this bottom will go to the top and this top will come below. So you interchange them. Remember, changing from a division to multiplication. So I will have my x plus 2, and then I've got my 5x minus 4 over 3 into x plus 2. I see some of you are like, when is it going to cancel these things out? Then relax, we're just doing it now. X minus 2, x plus 2. Then remember, you see, I'm doing the inverse. I'm inverting. What was on top is now at the bottom, which is this. It was on top. 5x minus 4 and 5x plus 4. But the multiplication here doesn't change anything, the 2 over x minus 2. Then now you can cancel once and for all. X plus 2 goes with x plus 2. The 3 goes with the 3 there. Alright, the 5x minus 4 goes with the first 5x minus 4. There is a 2 here which goes with the 2 on top there. And then I've got x minus 2 going with one of the x minus 2. So wherever you're getting it's a 1, it's a 1, it's a 1, it's a 1, there is x plus 2 remaining. You write it, x plus 2 over. Then at the bottom also, when you cancel, you get 1, 1, you've got 5x plus 4. So the answer therefore becomes that. Question: how do you test? Remember, test. How do we test this? What do? I choose any value of x. For example, I say let my x becomes 7. So I take a calculator, and in the calculator where there is the final answer here, where it's quicker, in the final answer, you see, I put my 7. So where there is x, it will be 7 plus 2 over 5 bracket 7 plus 4. And let's notice the answer is 3 over 13. Just keep this answer in your head. 3 over 13. I come and do the same thing. When there is x, I put 7 in the original to see if I'm getting 3 over 13. So it's 5, 7 squared plus 6, 7 minus 8. Where there is x, I put 7. Remember, 3, 7 plus 6 to get that 3 over 13 divided by 50 into 7 squared minus 32, and then over 3 into, actually it was 50. I hope you picked that. It's an error there. Just look at this. I said 5. It will make everything wrong. It's 50 there. It's good that I picked that one up early because it messes up everything. 3 into 7 squared minus 12. So if you don't put things right, you'll end up thinking you're wrong while you're right. You must make sure that whatever you're doing, 7 minus 2, you're doing right. So think of this. Then I must get 3 over 13. There is the answer, 3 over 13. Means my simplification is correct, and I have more assurance that this final answer here is correct. So this is how we solve this problem. Guys, this was all in all 20 marks, and I feel like it was a good 20 marks for you to work on. Now let us look at the last part of question 2, and we are now looking at question 2.2.2. This is the last 20 marks of this question. As you can see, we are now looking at 20 marks, and this question is 4 marks also. We are looking at 2.2.2. Now this is an addition, subtraction of fractions, and in this case we are subtracting 3 over 3 minus x over 6 plus x minus x squared. Now it is not complicated. There are some questions actually that these are questions that they are repeating. I have seen a similar question, but now what is more important here is you are going to be using the product sum on that one. And if I use the product sum, remember you have got 6 plus x squared. To factorize that, what you have is your product is that, which is p here is 6x squared. If I can just give more space there. So you have 6x squared, actually it's negative 6x squared, and then the sum is positive x. The factors of 6, remember, is the factors of the product. So the factors of 6 is 1 and 6, and we have got 2 and 3. So in this case, the one that is needed is 2 and 3. So it's plus 3 and negative 2. So that is what we're looking for, and then they need to be x. So these are the factors we are going to use. So if I write it now in a factor, to factorize that, what I have here will be 6 plus it was plus 3x minus 2x minus x squared. And then if I take the first 2 and the last 2, now in the first 2 what I have is 3, which is common, and when I factorize, I've got 3 into 6, I've got 2 plus x, and then I've got minus 2x. Actually it's not minus 2x, it's negative x, because 2 is not common there, it's negative x, and then negative x into negative 2x, it's 2, and then plus x. Remember, the brackets have to match. So when you have that, what I have then becomes 2 plus x in the brackets, and outside the brackets I have 3 minus x. So this is what I have. Now it means then when I'm solving this question, it will be equal to, so if I can continue from there, it will be equal to 3 over 3 minus x. You see, I've got 3 minus x on the first one, and minus x over, now look at this, 2 plus x, and you also have the 3 minus x, which is also appearing on the other first, the first side of the fraction. So you see you have got 3 minus x there. So the common denominator now, it is 3 minus x. That's the highest common factor, the lowest common multiple in a way, 2 plus x. That's what I'm working on now. So you're saying 3 minus x into 3 minus x, it is 2 plus x multiplied by the top, which is that. Remember, here I'm using the concept of addition and subtraction of fractions. Again, this is dealt with in the curriculum. I also deal with that in my videos. Now 2 minus x, this over this, you get a 1 minus that, it will be minus 1x is 1 times negative x is that. Then when you've done that, you have to open that bracket there, which is 3 times 2 is 6, plus 3 times x is 3x, minus x or 1x, all over, you've got the same bracket, 3 minus x, and then you've got 2 plus x. Alright, so when you continue at the top, what you will be having now, if you have it to be 6, 3 minus x is 2x, so 6 plus 2x over 3 minus x and 2 plus x. And then when you continue that, factorize 2 on top, you have got 2 into 6, it will be 3 plus x, right, over 3 minus x and x plus 2. So this seems to be the final part. If you can check, remember there is a way that you have to test your answer just to see if ever you have reached the end, because here 3 minus x and 3 plus x are completely different. Now you choose any value. As I said, it looks more like it was still going further, but let's just test our answer. Let's choose any value. For example, let's say x is equal to 4. So what I'm going to do, I'm going to input the value of 4 in the original. So I've got 3 over, then I've got 3 minus 4, and then I have minus fraction. Remember, my x is 4 over 6 plus 4 minus 4 squared. Since it's positive, even if I don't put a bracket, there won't be much of a difference. I'm getting negative 7 over 3. So here it's negative 7 over 3 that I'm getting on this value. Now let's try it on my final answer and see what it's giving me. So I will have fraction, I've got 2, 3 plus 4, remember my x is 4, over 3 minus 4, and then I have got 4 plus 2. Now it must give me minus 7 over 3 if it's correct. You see, I'm still getting minus 7 over 3 also here. So which means the simplification from the beginning up to the end, I haven't changed anything, it's still matching. So I have to just check to see, is there anything further that can be done on simplifying that? And if there is nothing else that can cancel out, then this becomes the final answer. So remember, you don't need to show this part because it is only for testing purposes. Alright, so this is the end of question 2, and as I said, it was giving you 20 marks, a good bonus for you to get all those 20 marks. Now let us move on to look at question number 3. And question number 3, let us see what it was involving. Now the first one is question 3.1, and question 3.1, you can see here it is 2 marks. Says solve for q given that, minus 2 is equal to 3 minus 4q. So this one, you are making actually q the subject of the formula. So let me just solve it quickly on the same workspace. I've got negative 2 is, now when you see this sign, let me just expand this. When you see this sign here, the sign says square root. When you look at that sign, which is the square root sign, what you need to know about that sign, I think I've already mentioned it. It means it's power 1 over 2. That is that sign. So here you'll have 3 minus 4q. Alright, so that's what it means. Now for you to be able to remove the sign, you can multiply by 2 over 1, power 2 over 1, but what you do on the left, you also do on the right by 2 over 1. So in actual fact, you're allowed to take it directly from the question to say minus 2 is equal to square root of 3 minus 4q. So if you do this, you square. That's what we're doing on that part with when you're multiplying by power 2. It is actually a doing. So when you do that, minus 2 squared, the calculator will give you a 4 because it's minus 2 times minus 2. Now the squaring was removing the square root, so you'll have 3 minus 4q. Alright, so you can take 3 to join the 4, which is 4 minus 3 is equal to negative 4q. Now 4 minus 3 is 1 is equal to minus 4q, right? So to just finalize, you divide by negative 4, divide by negative 4. Remember, your aim is to remain with q, so minus 1 over 4 is equal to q. So now we have managed to make q the subject of the formula, or we have managed to solve for q. Again, this can be tested. What you do is you input the value square root of 3 minus 4 bracket. Remember q, you say it is negative 1 over 4. So negative 1 over 4. Just to test if you're going to get a negative 2. If you get a negative 2, it means you're correct. But now it's minus 4. It's actually giving me a positive 2. So in this case, since it is not giving me the answer, then you're going to say minus 1 over 4 is not equal to q in this case, because when you're solving that, you can see that it does not give you the answer. So you need to test it. Let me repeat again. When we're testing it, if you say square root of 3 minus 4, now remember 4 times, just to show you, say times negative 1 over 4. My answer when q is, after solving for q, I must get a negative 2, but I'm getting a positive 2. So it's more like I'm saying minus 2 is equal to 2, which is not correct. The 2 are not equal. Therefore, the correct answer, though it looks strange, you have to write it as is. Just say minus 1 over 4 is not equal to q. They will mark you that answer correct, because that is the solution that we're getting in this case. All right. Now let us move on to 3.2. Now 3.2 says solve for x by using the quadratic formula. So just for this one, let me use a fresh page. Now this was in mark allocation. This is 3 good marks. As you can see, we're done with that one. Now if you look at it, this was worth 3 marks for 3.2. That's where we are now, and we are solving for x. Remember, they are strict here. Use the quadratic formula. So it says x squared minus 4x is equal to 2. So if I can use a fresh page here, which says x squared minus 4x is equal to 2. Just to check again, x squared minus 4x is equal to 2. Now because they said I must use the quadratic formula, you need to go to the back of your formula sheet and look for the quadratic equation. Is the one that is given as roots. You can see This is the equation here. They say the roots of the equation. So that's your quadratic equation that you're supposed to use. So x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. So that's the formula that we will be using for the quadratic part. So if I can write it down here, it says x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Remember, the division line must overlap the negative b and the whole of the square root. Now, when they give you a question like this, the reason why it was 3 marks, the first things that you needed to do was to ask yourself, is this the general, is it arranged in the general form? Now, the general form says a x squared plus bx plus c is equal to 0. So you can see that the first one is not arranged in the general form. So what it needs to do is take 2 to the other side, then you will have x squared, in this case, minus 4x minus 2 is equal to 0. Now you see that we have managed to match it as it appears in the general form. So remember, this is very important because it helps you to see that it's arranged in the general form. Now you start to match. Now if it's x squared and there is no number, it means there is a 1 there. So it's 1x squared. Now when you start dividing, where you have your x squared alone and you have like that, you can see that a is equal to 1. You do the same thing when you cut it at x and x, and when you're cutting it like this, you can see here that your b is equal to negative 4. And lastly, if you look at your c, this is the part of c. In this case, your c is equal to negative 2. So these are the values that as you're seeing them from that. That's what we're going to input in our x. So where there is b, remember the formula has a negative, so where there is b, I put negative 4 because b also has got its negative and the formula has its negative. So you see there is a negative there and there is a negative there. But what is more proper is to put that bracket there. But even if you didn't put the bracket, it's fine. Plus or minus square root of minus 4. Now if you write it like this, you're going to get it wrong because, let me show you with the calculator. If I say minus 4 squared, you see I'm getting a negative 16. But if I put the brackets and say in brackets minus 4 squared, instead I'm getting a positive 16. This is the right way to do. Also, don't be tempted to do it like this. You start with the bracket, you say minus 4 squared, you close the bracket. This is as good as you didn't put the bracket. So remember how you do it. You put a bracket, you put a bracket, the negative form must be inside the bracket and the square outside. So it's minus 4, my a is 1 and my c is negative 2 all over 2 and my a is a 1. So then you find your two values of x to say the first value of x is when you do that in the quadratic formula, minus bracket minus 4 plus square root, start with the positive one, you can start with the negative if you want, minus 4 squared, see how I'm entering it, minus 4 into 1, actually it's a 1, minus 4 into 1, and that into negative 2, right? And then you have divided by 2 times 1. When you say equal to, you see I'm getting the first answer, it's 2 root 6. Let's do the second one. It's 2 plus root 6. Delete, put a negative, is 2 minus root 6. So the first answer was 2 plus square root of 6, or x is equal to 2 minus square root of 6. Now let me get back to the previous answer. They say I didn't read the whole answer. It says solve for x by using the quadratic formula. They gave that. Now I'm seeing it now. It says the final answer must be rounded off to 3 decimal places. So it's very important now that I was supposed to read that answer in the question in full. So to round off the answer in 3 decimal places here, if I take the calculator, remember it's 2 plus square root of 6. So it will be 2 plus square root of 6. I'm getting, if I press SD, they said 3 decimal places is 4,449. You can use a calculator to round off for you. Shift, setup, use 6 and then fix it to 3 decimal places. Press SD again, is 4,449. So the first one here is 4,449. That's the first value of x. Or the second value of x is 2 minus root 6. And you press SD is 0,44. It's negative 0,449. You can still use the calculator, say shift, setup, 6 and you round off to 3 decimal places because it's 0 to 9. Press SD, minus 0,449. So that is how you can solve for the values of x, in this case like that. Now how do you test your answer? You can test your answer. I think you have seen that I prefer testing all my answers. I will just use one of them. For example, let me use the second one, 2 minus root 6. So if I go to my question here, you must always test with the original. Remember, one of the answers was 2x was equal to 2 minus root 6. So what I do is, with the calculator, where there is x, I will put that answer to say bracket 2 minus root 6, that is my x. In this case, play forward like this. That was x squared minus 4 and into 2 minus root 6. See that? Now, if it says x squared minus 4, it must give me a 2. You see? There is the 2 that I'm getting. So, which means it's correct. If I can just change and say 2 plus, put a plus because the other one was 2 plus root 6. If I even do that, I will still also get a 2. So it means my values of x here, these two values of x, they are correct. X is that and x is that. So that is how you use the testing of your answers to check if ever you're doing it the right way. Moving on to the next question, question 3.3. And this question is also 4 marks. Look at this question 3.3 here. That's where we are. And you get 4 marks. So this question, what is it talking about? It says 5 pears and 2 apples cost 16 Rand 50, while 3 pears and 4 apples cost 18 Rand 50. Says what is the cost of 1 pear and 1 apple? Maybe if I can try it here. It's 4 marks. I hope it's gonna fit well. So look at this. You have to come up with some word problems. Says 5 pears, so we're going to say P for pears, and 2 apples, we're going to say A for apples. Cost 6 Rand 50. Let's come up with an equation there. These are simultaneous or simultaneous equation. So 5 apples, so 5p plus 5 pears, which is 5p, plus 2 apples, which is 2a, they say equal to, or they cost 16 Rand 50. That is how you do simultaneous equation. That is part 1. Says while 3 pears, so remember it's p, so it's 3p, and 4 apples for a, they cost that much. So again, another equation, 3p plus 4a is equal to 18 Rand 50. So you see, this becomes your equation 2. Now the question then says, what is the cost of one pear and one apple? So this is a simultaneous equation. You just have to solve it the way we solve simultaneous equations. One of the simple ones, I will use the elimination method. And in the elimination method, what I'm going to do, I will take equation 1. I want to eliminate 2a. So I'll take equation 1 and I'm going to multiply it by 2. Let's multiply equation 1 by 2. So 2 times 5, I'm getting 10p, plus 2 times 2a, it will be 4a. So that was the aim, to match the a and the a. 4a is equal to 16.50 times 2. When we do that, 16.5 times 2, it gave me 33. So I have that 33. So when I've done that, I can now solve it. So what I do is I roll off and I subtract and put like that. So what I'm subtracting, I'm saying 3p minus 10p plus 4a minus 4a. Remember, this negative is affecting the 4a, so 4a. So what I'm doing, I'm saying 3p minus 10p, which is that, 4a minus 4a, which will be that, and 18.50 minus 33. So it will be equal to 18.50 minus 33. Alright, so 3p minus 10p, I've got negative 7p there. Then 4a minus 4a, that's the reason why I was matching that, is equal to, and then what I do then, I have to subtract 18.50 minus 33. Then it will give me minus 14.50. Alright, then I have to divide by negative 7 just to solve for p. So for p, it will be equal to, and I have in this case negative 14.50 or 14.50 divided by negative 7. Then it will give me, in this case, you see, I have to round off to the nearest cent, which is 2.07. So p is, remember, it's money, it will be 2.07 cent. Now after that, I have to find, in this case, a. So I can take any of the equations. Let's say I'm taking equation 2, which says in equation 2, 3p plus 4a is equal to 18.50. But remember, I know my p now is 2.7, so which is 3 bracket 2.07 plus 4a is 18.50. Then after that, take this to the other side. I will have 4a is equal to 18.50 minus 3 times 2.07, right? So when I've done that, again use a calculator to get that, which is 18.50 minus 3 times 2.07, and then I will get 12.29. So which means 4a is equal to 12.29. Divide by 4 like we did previously, and you'll get your value for a, which is a is equal to, and it will be 12.29 divided by 4. So you'll get 3 rand to 2 decimal place. Remember, money is up to 2. 3 rand 7 cents. So which is 3 rand 7 cents. So this is what you'll be having. Now remember the question, you have done everything, but now you have to conclude your answer. The question was, what is the cost of 1 pear and 1 apple? Then you're going to say 1 pear in this case. So it's 1 pear cost. Then you're going to say 2 rand 7 cent. And 1 apple cost, and then you're going to say 3 rand 7 cent. So this is how you're going to conclude now your answer, so that you can have your formats. So that is that. This is how you were able, if ever you were working on such a problem, to solve it. You could have done that. So this is how you do that. Now moving on. The next question here is, we're done with that part 3. We're now looking at 3.4, and this was 3 marks. It says you are given A is equal to that, which is pi r squared minus r squared, and then says make r the subject of the formula. So here we are making subject of the formula, and the thing is that we are given, remember, they are saying A is equal to pi, and then we've got the big R minus the small r. Right, now the first thing first, you have to get rid of that pi. So to get rid of that pi, divide by pi, divide by pi. That is the first thing that was important there, so that you can have that. So you will have A over pi is equal to r squared minus r squared. So that is the first part you could have done. Now the next thing, remember they want the small r. What you can do, there are 2 ways you can approach it. You can take the small r to the other side, because it's already negative, but when you make it jump, it will become positive r squared. Then you take the A over pi to the other side to join the big R. So it will be r squared minus A over pi. Why were you doing that? We're avoiding to remain with the negative r. Then when you're done with that, to remove the square, you square root. To remove the square, you square root. When you do that, you must say plus or minus. So you've got r is plus or minus square root of r squared minus A over pi. This answer was acceptable. Some may want to add the fraction inside there. Still fine, but this answer was already fine. You could have stopped here. This answer is sufficient. Or if you want to add, you're going to say plus or minus square root of. If you're going to add, you will have r squared minus A. I think it will be pi r squared like this minus A over pi. That is if you wanted to add and get it like that. The answer was still going to be fine like this. Now a quick one, just for the sake of others who thought maybe this was not their preferred method. There is a simple another simpler version of it, or similar version of it, is whereby, remember, you are given pi, here is r squared minus r squared. Some would have preferred to say, why can't I open that bracket? It was fine. You're going to have A is pi r squared minus pi the small r squared. Right. Then after that, you do the same thing. This pi r squared is negative already. It will become pi r squared is equal to, let the A join that one, which will be like that, minus big A. Then divide by pi, divide everything by pi. Then after that, you're going to say r squared is equal to pi r squared minus A over pi. Then after that, square root, then is plus or minus, you also do the square root, which is similar now to say r will be that. We did that, get that similar answer. So this is how you can do the subject of the formula in that part. And I hope you guys are still benefiting from this session. And remember to subscribe to our channel if you have not done so, or also share this channel with your friends so that they can also benefit. And if you want more of these resources, guys, I keep emphasizing, there is a textbook which is Mathematics N2 for the underdogs, and you can purchase it. And by the way, it also comes with a complete set of videos for the whole curriculum, so, and it comes at a good cost. Now moving on, 3.5. Now in 3.5, it's also 3 marks. If I can look at this one, it says make D the subject, make X the subject of the formula there. They are looking for X. I think we can also work it even from here. So if you want to make X, so what are given? We are given D is H plus X squared over 4H. So I need to make X. So what you can do, you can see the H and the H and that is separated by the plus sign. What does it mean? It means this H can join the D, so you'll have your D minus H is X squared over 4H. So far so good. Now to get rid of that fraction, you multiply by 4H on the left, but remember what you do on the left, put a bracket, also multiplied by 4H on the right hand side, but don't forget to put a bracket so that you have got 4H multiplying not only the big D but also the H, because it's affecting everything on the left hand side. Hence you put a bracket. This is equal to X squared. Hope you are seeing that. Now we are solving for X just like we did previously. You put a square root to get rid of that square sign. You put a square root again on the other side. Now when you put a square root, it's plus or minus. So you can then say, therefore, X is equal to plus or minus square root of 4H, and then in bracket, the big D minus the H. So this is how you could have solved or make X the subject of the formula in that case. Alright, I hope this keeps making sense to you guys. This was 15 marks and you could have scored all your 15 marks there. Now let us move on to look at question number 4, and it says, alright, there is question number 4, says KFC intends to start selling, KFC as the company intends to start selling milkshake in a crispy conical shaped cup with a surface area of 315 square centimeter and a slant height of 15 centimeters. Now calculate each of the following. So here, if I can bring this up in a page, they are saying they intend to start selling a milkshake in the shape of a what? Conical. It's a cone. It's a conical shaped cup, so it's a cone. So now what you need to do, or what they're trying to bring to you, is for you to say, can you sketch that? So I'm going to try to sketch that. So what you're having is, picture you want to sell a milkshake, they're saying it's in the shape of a cone. So you'll be having something like this. This is the shape of a cone. So if that is that part, so then they are saying here, the area of that cone is that, and the slant height is 15 centimeters. That's what I wanted to. So from here, use a different one. From this side to this side, if you measure it, it is 15 centimeters, and also the area there, which is if you look at around that shape, the area A is equal to 315 square centimeters. So 315 centimeter squared, that is the area. Now let us look at the question. Now the question says calculate each of the following, and they are looking at 4.1.1, which is 3 marks. Now it says the radius of the cup. So if we come here, they are looking for the radius, so which is the distance. If this was the center, they are looking for that distance as the radius. So that is the radius of the cup. But in all these questions, when they start talking about shapes, go to the formulas. I think if I go to the formulas here, let me just look for the formulas. There are the formulas, and in these formulas I'm looking for the cone, and there is the part which talks about a right cone, and I'm looking in this case, says the one that talks about the surface area is this one. And this formula has got different parts. There is the one that talks about the slant height, which is the second one, which is pi RL plus pi r squared. The L there is the slant height. So if I take that formula, pi RL plus pi r squared, into my equation to say SA, surface area, is pi RL plus pi r squared. So this is the formula that I'm going to be using as the surface area. I took it, as I said, from the formula sheet. So now when I'm using this formula, how do I use it? The question first says I must calculate the radius r. So for me to find r here, I'm given already the area. So I'm going to say 315, where there is the area, is equal to pi r, where there is the slant height, put a bracket, they told me it's 15, plus pi r squared. You see that? So when I continue to simplify it, I have, in this case, 315 is equal to pi r15 will be 15 pi r plus pi r squared. Now, given this, how do I simplify this? Now you will have to recognize that if I take 315 to the other side, it will be 0 is equal to, and I rearrange it, it will be pi r squared plus 15 pi r, and the 315 will become minus 315. And you can see that this becomes like 0 is equal to a x squared plus bx plus c. That's what you're having, which means this is a quadratic equation, but wherever there is x squared is now r. If you cut here, you can see that now in this case my a here is equal to pi, and my b, remember I'm cutting at r. If I cut at r and x, so you can see that the b there is 15 pi, and my c is in this case outside, which is negative 315. So the formula, just like we did, I said go to the formulas, you look at this formula for the quadratic equation. That's the formula you are using. The one says minus b plus or minus square root of b squared minus 4ac over 2a. That is what they needed there. So what you need to do is to write the formula to say x, but now you're not finding x, it's r is equal to minus b plus or minus square root of b squared minus 4ac over 2a. So your r there will be equal to minus, and then the b, we say it is 15 pi, put it in brackets, don't forget, plus or minus square root of b squared, it's 15 pi squared minus 4, my a is pi, my c is negative 315, and it's all over 2, and my a is pi. So this is what you are having there. Then you got your r is equal to, so you use your minus, in this case in brackets, 15 pi, there is my pi, start with the positive, plus square root of 15 pi squared minus 4 bracket pi bracket negative 315. Just need to be careful when you're doing this, over 2 pi, but you can put it in brackets, but it doesn't change anything. You see, the positive one is 5. I need to get both numbers now. It's 5,010, almost 5, but in 3 decimal places 5,0106. But if I say shift setup 6 and 3 decimal places, if 5,011, remember 5,011, put a negative 1, it's 20 minus 20,011. So I've got 5,011, or r is equal to negative 20,011. Now remember, I'm looking for the radius. I cannot have a radius of a negative. So where there is the negative, you say r cannot be, or you can say not a solution. So that one is important because you need to make us aware that this is not a solution. So the answer there becomes r is equal to 5,011. Now you're dealing with some units. If you forget units, that will penalize you. So it will be in centimeters because the area and the slant height were in centimeters. That's why they made it 3 marks, I guess, but it was a little bit demanding. Now, I will encourage you, of course, to go through it in a way so that you can get more practice of how I use the quadratic equation there. 4.1.2 says we must find the perpendicular height of the cup. This is now 2 marks. Now, when we're looking for the perpendicular height, if you go back to our formulas, you see these were 2 formulas here. Then the first formula actually talks about the perpendicular height, and the perpendicular height has to deal with that h. So what you do is, when they talk about the perpendicular height, we have to write that formula to say pi r h squared plus r squared plus pi r squared. So if I write this formula here to say we have got also surface area is equal to pi r, and then there was square root of r squared, h squared, it was h squared plus r squared plus pi r squared. I just need to know to see the first part of it. It was pi r multiplying that. So this is the formula, and I think I wrote it correctly. So you have that. Now they are looking, remember, for the perpendicular height in this case. Now also, if I go to my formula here, remember when they talk about the perpendicular height, I'll use my red, they are talking about this distance here. Alright, so actually I'm using the wrong method here, because this distance, you can see that I'm coming with a triangle. Just look at it. There is that part, and then there is that part, and there is that part, and there is a good part there. I just want to show you something. If I draw it also outside here, it is like this, and it was like this, and it was like that. So I was using a wrong formula. So what you're looking for, there is a 90 degrees that is going to be formed there. What you're given is your radius, which we just calculated, which is 5,011, and the slant height, remember they told us, is 15 centimeters. I think you see where it's going. So here it's also centimeters. Now you are looking for this distance. I can't call it x in this case, I will call it h, because already they told us is the height. So you can see that this is the theorem of Pythagoras, which says 15 centimeters squared here, 15 squared is equal to h squared plus 5.011 squared. So to find h squared, this one joins, which is 15 squared minus 5.011 squared is equal to h squared. Then you square root both sides. Make sure the square root covers everything. Therefore, you can now say, therefore h is equal to, then if I use a calculator now, you need to use it once to say square root of 15 squared minus 5.011 squared. You put a square root, it's 14.138. Shift setup 6, then you say 3 decimal place, 14.138. So that is what you'll be having. Remember, in centimeters, that is your slant height that they're dealing with there. So you can have it there to say the slant height is 14.138 centimeters. And remember, it was the theorem of Pythagoras that was working there. Moving on, then they say calculate the following. Still continuing. We're done with this part. Now we are looking at the next one, which is 2 marks also. It says the quantity of milkshake that will fill the cup. Now quantity means volume. That word quantity there is about V, the volume. So you got your formulas and you identify the volume. So you can see this is the formula for the volume, which is 1/3 pi r squared h. So you come here and identify to say V is equal to 1/3 pi r squared h. Now that's the quantity, so V is 1/3 pi. Now the radius, remember, is 5,011 squared, and then the height there is, we just found it, 14.138. So you're now using those values that you're calculating to simplify the for the volume. So it's 1/3, actually it's not 33, it's 1/3 pi, so shift pi, then in brackets 5.011 squared, and in brackets 14.138. Then when you do that, it will give you the volume, which is 371.762. Shift setup 6, 3 decimal places, 371.762. So it's 371,762. This is the volume, but remember, volume is in cubic centimeters. So the conclusion, the question was calculate the quantity of the milkshake. So you're going to say quantity is 371,762 cubic centimeters. So that is how you could have done this particular question 4.3. Now let us move on to look at question 4.2. Question 4.2 is 3 marks. You can see here 4.2 is 3 marks. Says the coordinates of the points on a curve are given in the table below. So this one is finding the coordinates of a point. Calculate the area of the irregular shape. Now area, in this case where you're given coordinates, it's where you use the ordinate formula. The ordinates formula. Now if you go to your formulas, in this case, if I can check on the formula sheet, there is the part of the formula that deals with ordinates. And let me just check the mid-ordinate rule. That is actually the right way. So there is this formula which deals with the mid-ordinate rule. So this particular formula there are 2 of them, but I'm going to use the last one. It says area is equal to first ordinate plus last ordinate over 2 plus sum of all other ordinates times distance between ordinates. So I'm going to identify the first ordinate and the last ordinate, divide by 2. First, remember, it's a big bracket. So what I'm going to do here, when they talk of area, I'm going to say area. Alright, so its area is equal to, now what is what in this table? You must know the x values is the distance between ordinates. Let me just look at this. This is distance between ordinates, and this is where you are using the formula. If they say first ordinate, so you come here, this is your first, you go to the last one, and this is your last. So your first and last is going to be bracket 5 plus 6, these are the y values, over 2, and then plus sum of all the other ordinates. As you can see from this, it says plus sum of all other ordinates, and then times distance between ordinates after closing that bracket. So when you come here, you will have, now you are adding these ordinates. So what you have is plus 10 plus 60 plus 70 plus 40 plus 20 plus 12, right? And then close it, times distance between ordinates. Look at the distance is consistent. 0 to 3, it's 3 distance. 3 to 6 is 3. 6 to 9 is 3. 9 to 12 is 3. 12 to 15 is 3. 15 to 18 is 3. And then 18 to 21 is 3. So that is the distance between ordinates, which is 3. Then you can use a calculator straight away. It can give you the answer. So what you'll be having is bracket, and then you've got fraction 5 plus 6, just to verify the first was 5, the last was 6, which is correct, over 2. Then plus sum of ordinates, which is 10 plus 60 plus 70 plus 40 plus 20 plus 12, close it, and then say times 3. Then you get this answer there, which is 652,5. So 652,5. Now remember, they're saying the area, they didn't specify units, then you can say units squared. Some they say u squared is still fine, standing for units. So this is the area of the irregular shape that they were looking for. So that's how you solve this particular question. Now let's continue with the next question there, 4.3, and see what it was dealing with. 4.3 is dealing with graphs. Now functions, says the function f of f 3x plus y is equal to 6, and g x over 3 minus y over 2 is equal to 1. Says draw on graph paper the functions f and g on the same system of axes, clearly indicate the intercept with the axis. So this question is in two forms, but one thing you need to know is you are dealing with straight lines. You can see 3x plus y, so you have to write it in the form, that is the key, write all of them in the form y is equal to mx plus c if you want it. Then you're going to be able to use to find the y-intercept, or you can just do it so quick to plot points. Find 2 points, it's always like this, to draw a table which has x and y. You need 2 points in a straight line that will join. You come, this is for f of x. Now I'll say for f of x, then divide it for g of x. You do the same thing. You have a table that will give you two values. You'll see the values x and y. So the values are always the same. When x is 0, what is y? When y is 0, what is x? Similarly on the other one, when x is 0, find y, and y is 0, what is x? So you take a calculator to say here, I'm in on the first one here, when x is 0, you can see 3 times 0 becomes 0, y becomes 6. And then the other one, you do the same thing and you say, what happens when y is 0? So when that is 0, 3x, you'll have 3x is equal to 6 over 3 over 3, which means x is equal to 2. So you'll have 2 there. Those are 2 points which you're going to draw and join together. Same thing on the other side. You do the same thing when x is 0. So when there is 0, so 0 over 3. So you'll have here minus y over 2 is equal to 1. You multiply by negative 2 times negative 2. The negative affect the negative. The 2 cancel the 2. So you'll have now your y is equal to minus 2. You see that? And then you do the same thing and say, what about when y is 0? So when y is 0 here, what you have is x over 3 is equal to 1. Multiply by 3. Multiply by 3. You are solving for x, so you see that x is equal to 3. Again, these points are called the x-intercept and the y-intercept points. So you're looking at the point when x is 0, you find y. When y is 0, you find x. Then you plot these graphs. So as I said, I'm not going to do it on a graph paper, but I'm going to use my own graph here. If I can just use that and actually make it a little bit, it's too big now. I think that would be fine like that. So let's say I'm going to plot it here, and this is the graph paper I'm going to use. Now if I divide my line here and use something visible, let's say I've got this point like that, and I've got a point like this. I hope this will be fitting well. So remember, first thing you need to do your graph. These are the y-axis, you need to label them, and these are the x-axis. Very important to do. Then you have to mark your graph. Now go back and look at your point. The highest value on the f of x of y is 6, and then the highest value, the lowest value is actually not showing, there is no negative. And on the other one of g of x, the lowest value is minus 2, the highest value is 3. So your graph must be within that range. To say here it's 6, so you have got 1, 2, 3, remember up is positive, 4, 5, 6, we can go for 7, but it's not necessary, and then negative 1, negative 2, negative 3, I think that was the last one, we can go for negative 4, positive 1, it's 1, right hand side is positive on x, 2, 3, 4, 5, then again negative 1, negative 2, negative 3. But now if I check on the x values, actually x values, the biggest value is 3 and the smaller value is 2. I could do it this way for the x values because the values are small. It was also fine for me to actually jump 2 spaces, and after 2 spaces I could have done this. Just want to show you, to say, because the values are much smaller, to jump 1, 2, then here I get my 1, jump another 2, let me use a different marker, like this is 1 for me, jump 2 squares, this becomes 2, jump 2 squares, this becomes 3, jump 2 squares, this becomes 4, again jump 2 squares, it's negative 1, jump 2 squares, negative 2, jump 2 squares is negative 3. So basically it was much better for x to jump every 2 squares. Now let's join the points. Says the first one I'm working on is this point, which says when x is 0, y is 6. So you come here and say when x is 0, y is 6. There will be a point there. And the last point is when I'm working on this one, when x is 2, y is 0. So when x is 2, y is 0. You see, these are intercepts. As I said, you just have to join those points. So when you do that, you draw that line. Let me use that to say this is the line that you are having. So you just have to, because I don't have a way of having it straight on both sides, but this is the graph and you have to label it to say this is your f of x graph. You understand? Then you do the same thing, go back, plot the g of x. When x is 0, we're looking at this point. It's not clear there. We're looking at this point now. It says when x is 0, y is minus 2. So you go to x is 0, then y is minus 2. You have a point that side with my red. And then the other one says when x is 0, when x is 3, y is 0. When x is 3, y is 0. So when x is 3, y is 0 actually is correct. That like that. So now when I plot the graph, what I'll be having is, it's more like I have that, and see, it's more like the graph was like this. So that is what you are having. And this one, remember, we call it now g of x. So this is how you could have plotted those graphs. Now if I go back, the question is provide, then it says it said here draw. Let me just erase. The question was draw on a graph paper the functions of g of f and g on the same system of axes. So we did that one. Clearly indicate the intercepts with the axis. So let me go there. When they say clearly indicate the intercepts with the axis, so they're saying you must clearly show that the graph is cutting at that point, and we are able to do that. You can even do it in coordinates to say this is 3, 0. You can write this 3, 0 there, not at the bottom. And then the other one here, you can write it and say this is 2, 0, and the other one is minus. It's 0 actually, and minus 2. And the top one here is 0, 6. We are trying to clearly show the axis there, the coordinates of the axis. Then the next question, 4.3.2, because we just did the first one, provide the coordinates of the point of intersection between the graphs drawn in question 4.3.1. So you come here, and now this mustn't be as accurate in a way, but you need to be as close as possible. So that is the point of intersection there, if I can use. So they're talking about that point there. So in that intersection, the coordinates of the point of intersection, if you look at the x value, is that side, and if you look at the y value, you are looking at something from this end like this. You see that? So we are looking at y as in the center there is negative 0,5. So the coordinates there is negative. Actually, you start with the x value. So the x there, because it's positive, it's 2. In the center it was 2,5. So it's somewhere like 2,25 is to negative 0,5. You see that? So the answer there was that when the coordinates of the point of intersection 2,25 and negative 0,5. But such questions like this, just want to show you something. You are able to solve them in a way. So algebraically, you can just quickly test if, I know it's not going to be worth the marks, but you can quickly test if you're doing the right thing. What you do is you look at this equation. I'm just going to do it quickly, and then take x to the other side. You will have 3x plus 6, and that is y is that. Now again, on this other one, what you have, let me work on this one. It's, if I take y to the other side and 1 to the other side, it will be x over 3 minus 1 is y over 2. Then multiply by 2 times 2, but put a bracket, remember, so that you have got y is equal to x over 3 minus 1. So this will be the other y is equal to, let's open one step bracket, this time that it will be 2 over 3x, 2 times negative 1 there, it will be minus 2. So you have got these two graphs, you equate them. So what it means is you say 3x plus 6 is equal to 2 over 3x minus 2. This is that point of intersection. The two graphs are equal. So you solve for x. To solve for x, we can multiply everything by 3 to remove that fraction. Or what you can do, we can actually take this to the other side, take 6 to the other side. So 3x minus 2 over 3x is equal to negative 2, negative 6. Then, of course, then you need to use a calculator here to say 3 minus 2 over 3. It will give you 7 over 3. So you've got 7 over 3x is equal to minus 2, minus 6 is negative 8. Divide by 7 over 3. 7 over 3, and then you divide here by 7 over 3. Then you cancel there, you cancel, and you're going to have your value for x here. And then if I do that, it will be negative 8 over fraction 7 over 3. Press SD is minus 3,428. Don't know why we're getting a negative 3,428. I need to check if we did everything right here. Now from the first graph, I think I see where I made an error. You see, the 3, when it jumped here to join the 6, it became a negative 3. So let me correct that here and have a negative there. It's a negative there. So that is where things got wrong there, because I mustn't get a negative x from the graph, it was positive. Let's do it again. So if I have negative 3 minus 2 over 3, let's see what it gives me this time, minus 11 over 3, so minus 11 over 3x is equal to negative 8. Divide by negative 11 over 3, negative 11 over 3. So what is my x value? So x will be equal to a fraction negative 8 over fraction negative 11 over 3. So you press SD, you see it's positive 2,18, so almost 2,2. So x is 2,2. Then after that you find your y value, take any, for example that one says y is negative 3, 2,2 was the value of x plus 6, then it will give us y is equal to, now the y value can be negative because it was negative already, negative 3, negative 3 bracket 2,2, right, plus 6. It gives me negative 0,6. So it's minus 0,6. So algebraically, the points of intersection of these two graphs, x is 2,2. This is the accurate one. Y is negative 0,6. So my answer must be within closer to this range. But if I check my answer, x was, I said 2,25, which is much closer, and the y was negative 0,6, but I've got negative 0,5, so they will mark me that answer correct. So that is how you could have done that one. Alright guys, now let's look at the more questions. We are still in question number 4. We have done 4.3. Let's look at 4.4. It says the graph of y is graph of f, which is y is equal to 3x squared minus 6x minus 9, and g, which is x over minus 3 minus y over 6 is equal to 1, are shown below. So this is the graph that they've shown. You can look at this graph. You can see the graph of f here. There is f. It is this parabola, and E is that straight line. Alright. So now let's look at the questions here. It says determine each of the following coordinates. So they want coordinates here. Now A and B, x-intercepts of f. So let's look at A and B. This is A, this is B, and they're looking for the x-intercepts of f. So for you to solve this, I'm going to just be solving it here. So on the x-intercept, remember, along the x-intercept, you must conclude that y is equal to 0. So here, when you write this, you'll be having 3x squared minus 6x minus 9 is equal to 0. So you're solving for x, you can divide everything by 3. Divide everything by 3 there. You can see 3 is common. When you do that, you'll have x squared, right? Do that. 3 into 6 is minus 2x. 3 into 9 is minus 3 is equal to 0. So now you have to solve for x. Remember, you can do product sum, and when you do it, you will have here x minus 3 and x plus 1 is equal to 0. That is when you do your product sum. So x minus 3 is equal to 0, or x plus 1 is equal to 0. So when you take 3 to the other side, you have got x is equal to 3, or x is equal to, the 1 jumps to become negative 1. So these are the x-intercepts, the x-coordinates. Look at the question, says A, B, the x-intercepts of f. So you come here now and ask yourself, which one is A, which one is B? You can see A is negative, so it will be x is equal to minus 1. B is positive, so here x here is equal to 3, and the other one x is equal to 1. So if they ask that, if I can erase now because we have solved it, so here you'll be having x is equal to minus 1. So it's a matter of x-intercept, y is equal to 0. Then the next one, 4.4.2, I hope you see, they want the coordinates in all of these. That's why it was 2 marks. Now you got that. Now 4.4.2, it's saying the y-intercept of f. So you come here and say, if you're looking at graph f, the y-intercept, you must know, when you say y-intercept, x must be equal to 0. So what you have here, you'll have y is 3, 0 squared minus 6, 0 minus 9. So when you do this, this will cancel, you'll have y is equal to negative 9. So that's what you're going to be having. So y is negative 9. If you come to your graph here, which is that C, so here y is equal to minus 9. So that is that part. Then the next one again, That's why it was 1 mark. Look at the next one, 4.4.3, it's 2 marks. They want D, turning point of F. So they want this point D here. Now to find the turning point, you come here on this equation. Remember the equation is, in this case, when they're looking for the turning point, there is a formula. Before I do that, let me go to the formula. There is a formula that deals with the turning point. It's not here. Let's try the other formulas. There is this formula. It's the axis of symmetry, which says x is equal to minus b over 2a. So that is the formula for the turning point. So when you use it, you're going to say x is equal to minus b over 2a. Now you come back to your graph here. Remember, this graph is a x squared plus bx plus c. So you have to identify now. You can see a here is 3. You can match, and you need, next one is b. B there is negative 6. So you're going to say x is equal to, there is a negative for the formula, then b is negative 6 over 2 and a is 3. When you do that, it will be able to give you, so is that minus bracket negative 6 over 2, 3. See that? The answer is 1. So equal to 1. So when the question was, let me look at the question, it says D, the coordinates. Okay, so this question was looking actually for coordinates and I was not answering it right. So in this C, the coordinates of C is 0, minus 9, because you must be doing coordinates. So in the first one, I found the coordinates of D are found only when x is 1. So what you do, you go to the value of y. Remember, y is equal to 3x squared minus 6x minus 9. So when x is 1, where there is x, you put 1, which is 3, 1 squared minus 6, 1 minus 9. That is what you're substituting now. And then check your answer, which is 3, 1 squared minus 6, 1. Then we put a 1 and minus 9. It gives me minus 12. So y is negative 12. So these are the coordinates of the turning point. So D there will be x is 1, y is negative 12. And it makes sense because C there is negative 9. You can see that. Now if I correct the coordinates here, which was saying x is equal to minus 1, you must say negative 1, 0. And here when you said x is equal to 3, you must write it in coordinate form. So B is 3 and 0. Because you must answer the question they said in coordinates. Now we're done with that. Let's look at 4.4.4. Says E, the x-intercept of what? Of G. So if you go to E, let's look for E, which is that part, the x-intercept of G. So now remember, on G, the moment you say x-intercept, you must always remember y is equal to 0. So you come here and put a 0 there. So you'll have minus x over 3. Actually it's x over minus 3, like that. Minus 0 over 6 is equal to 1. So this will kind of become a 0. So it's not influencing anything. So what you do now, multiply by negative 3, both sides, negative 3, so that you have then, in this case, your x is equal to minus 3. So now the intercepts therefore will be negative 3 here and y is 0. That is on G. Alright, I hope you're following up, guys. And what about the next one, 4.5f, which is y-intercept of g. Again, you come here on g and you say under g y-intercept. So it was x-intercept, now it's y-intercept. Then you interchange. Before it was y is equal to 0, now it's x is equal to 0. So you interchange everything, you just oppose. On this one, in this time is x is the one that is 0. So you've got 0 over negative 3 minus y over 6 is equal to 1. You see that? So this 0 over 6 doesn't influence anything. Now you have to multiply by negative 6. You multiply by negative 6. Am I right? So what you're going to do, negative, negative, the 6 cancels. So y is equal to negative 6. So you look for the y-intercept, which is here at f. In that particular value of f there, what we will be having there will be, in this case, if I can just look at that. So we said y is negative 6, so f is 0 and negative 6. So you can see they were just trying to make us solve for intercepts here, whether it's x-intercept, it's y-intercept, but these were just good marks for you to do. And in total, question 4 was a lot of marks on it, 22 marks. Alright guys, now we're still continuing, just getting it once and for all, going first time doing this whole question. Is a comprehensive solutions of mathematics N1, by the way. Let's look at question number 5. Now question 5, let's look, it's more of trick here, but now the first one says convert here 78.3 degrees to 78.3 degrees to degrees and minutes. It's 1 mark. The calculator can quickly do that. You just say 78.3, right? And then it will be degrees, then you say equal to, there is the answer. It is 78 degrees 18 minutes. That's all. So this is equal to 78 degrees 18 minutes. I think you saw what I just did. You just come here in the calculator, you say 78.3 and then you press that, say equal to, it gives you minutes. But if you want to do it longer, you see this 78.3, it's actually 0.3 that you're converting to minutes. You multiply it by 60. You can see that it is 18 minutes. So it will be 78 degrees 18 minutes. Now 5.2, that's why it was 1 mark. 5.2 there says determine the following without using a calculator. Then say if sec alpha is minus this over this, where 90 degrees is less than or equal to alpha is less than or equal to 180. Now if they're giving you sec alpha is that, you must first, before we answer this, understand what is sec. Now sec is 1 over cos, so it's 1 over cos alpha is equal to negative 13 over 12, which means therefore cos alpha is equal to negative, you take that to the top, take this to the bottom, it's negative 12 over 13. Okay, and then that is what was more important there. Now then they give you the range where you expect it. It's between, you see when they're saying 90 and 180, so it's greater than 90 but it is less than 180. You can look at it like this: 0, 90, 180 and 270. So it's greater than 0, which means it's not here, and then but it is greater than 90 but it's less than 180, so it can't pass 180 again. So the range, this is where you find it. That's what they're saying. It is in the second quadrant. And in the second quadrant there, if they say I can draw that, it would be a line like this, and the coordinates there, that's what I need to find. So if they say cos, remember cos is the same in terms of x, y, and r. Cos is x over r. So which means when I do this triangle, remember I teach this again, I repeat again in my maths N2. So now if I want to find here, you have to find y. Remember it says y squared is equal to r squared minus x squared. So y is square root of r squared minus x squared. So my y is square root of the r is 13 squared minus, now you can see that the 12 is this one, it was 12 negative, r is 13. Now I want to find the y there. That is basically what we're doing there, to find the y. So in this case, minus bracket negative 12 squared. Then when I do that, it will be square root of, can put it in brackets, 13 squared minus negative 12 squared, which is 5. So y is equal to plus or minus 5. The right answer is to say plus or minus, but you can see that y is positive, going up is positive, so therefore y is positive 5. So now if y is 5, you can now solve. We've used this diagram. As I say, if you want to get more of this so that it can make easier sense, guys, you definitely need to enroll for my classes, and it will make things easier for you. Now when we have done this, because we have established, what you need to establish was to say my x is equal to negative 12, my y is equal to 5, and my r is equal to 13. That's why I was doing what I was doing, and this is what this question is all about. Once you know that, then you're able to solve whatever we need to solve. As you can see now, I can say 1 minus cot alpha. So if I look at that, this is now 3 marks. Now 1 minus cot alpha is equal to 1 minus, remember cot is 1 over 10, it's like 1 over 10 alpha, but 1 over 10 alpha is same as saying, remember 10 alpha is sine alpha over cos alpha. Now cot is cos alpha over sin alpha. That is what it is, you understand? So this is equal to 1 minus, now cos alpha, remember cos in this case, now let me write it again, cos alpha is equal to, we say it is x over r, which my x was negative 12 over 13, and what about sine alpha? Sine alpha is y over r, which is the y is 5 over 13. So that's what you're having. So you're having minus negative 12 over 13, then use this one divided by 5 over 13. Remember, it's more like I'm saying it now like this. It's cos alpha divided, which was over, divided by sine alpha, because there are many, protect it like this, there are many fractions. Then this is equal to 1 minus, so it will be minus 12 over 13. You change the division to multiplication, which is 13 over 5. See why I'm doing it? Because they said determined without using a calculator. So you want to prove that you never used a calculator. So which is equal to 1 minus, so that cancels. So you have got negative 12 over 5, and which is equal to 1 plus 12 over 5. Even if they say don't use a calculator at this stage, no one can prove you used it if you say 1 plus 12 over 5. It gives you 17 over 5. That's why it was 3 marks. So you're supposed to work on it up to that. Now the next one that they need, and you need to be always knowing this, sine squared alpha plus cos squared alpha, it must always give us a 1, because this is an identity that is common. But let's prove it there. If they say sine squared, so remember sin alpha again is y over r, and then cos alpha is x over r. So I'm gonna use it. Sin squared will be y, which is 5 over 13 squared, plus cos squared, it will be negative 12 over 13 squared. You see that? Then 5 squared is 25 over 13 squared, I think it's 169, plus negative 12 squared is 144 over 13 squared is 169. So if you add this, common denominator is 169. So you're adding 25 plus 144 there. That's what we're adding. So if we add the top, 25 plus 144, 25 plus 144, you see it's 169. So you have got 169 over 169. Then this cancels to give us a 1. As I said, this is an identity. Cos sine squared alpha plus cos squared alpha is equal to 1. So that is how you could have solved that. And yes, let's continue as we are towards the finishing of this paper. Now this 5.3, we're now looking at 5.3, says from the point on the ground where a policeman is standing P, we'll look at that, the angle of elevation to two criminals at the third X and sixth Y floors of a tall building is 21 degrees and 31 degrees respectively. If the policeman is 18 meters from the foot of the building B, how far apart are the two criminals X and Y? Now let us look at this diagram. So those are the criminals. This is a story building. So it's more like you have got a building like this, you know. So it's like this. So you've got criminals that they are far apart like that. That's what they're saying. Now they are saying then here the policeman P is looking at these criminals. So the angle of elevation, the first one is 21, the second one is 39. Now the question is, how far apart are the two criminals X, Y? So what they are looking for here, they want us to find this distance here. That's what they are looking for. Now, for us to be able to do that, I think let's have two diagrams to separate them so that you can see what I'm dealing with. We're dealing with a bigger triangle like this. This is the bigger one. And in the bigger one, we've got a 90 degrees, we've got criminal Y, and we've got B there, and we've got P there. And this angle that they gave was 39 degrees, and this distance is 18 meters. And then we also have a smaller one, which is like this. Alright, so this smaller one, remember, is not drawn to scale. Now we have got X, we have got B, you have got also 18, and you have got P. So that's what you're having. And now this angle is 21. Now whenever you're solving this, what you need to ask yourself is, what are they looking for? So here we're looking for this distance, and here I will call it y. This is what you're looking for, x and y. So now let's start with the first one, the one in red. To say, what are we given? We are given this is the adjacent side, and we are looking for the opposite side. And we must use the word SOHCAHTOA. You see, SOHCAHTOA. Now you need to know this from my lessons. Now SOHCAHTOA, we are looking, remember we're given opposite and adjacent. So SO has got hypotenuse, we don't want it. Ka has got hypotenuse. Tan has got opposite and adjacent. So what does it say? It says tan theta is opposite over adjacent. So tan theta, now we know the angle theta is 21 degrees, is equal to opposite, which is x, over adjacent, which is 18. So you multiply by 18 there, multiply by 18 there, you'll find x. Therefore, x is equal to, if you look at it, it's 18, 10, 21. So it's 18, 10, 21. It's not 8, but it's 18, 10, 21. 6.9095, which is 6.910. So remember, this is in meters. So this is that distance. We got it first. So you'll see what we do later. Now the next part is to find distance y. It's similar. I'll use SOHCAH and TOA. Now what I'm given, if I look at y, I'm not given the hypotenuse, so I don't want the hypotenuse in SO and Ka, but I'm given the adjacent. This is adjacent, and I need the opposite there. So this will work also, such that it's, if I use it now, it's 1039 is equal to opposite, which is y, over adjacent, which is 18. Multiply by 18, multiply by 18. So my y is equal to, it's 18, 1039, 1039, which becomes 14.576. So it's 14.576, and the unit is in meters. So what am I saying here? I'm saying this distance here, from here to here, is 6.910 meters, and I'm saying the distance from the top to the bottom is, I just found it, is 14.576. Now the question is, what is the distance in red here? What is this distance? Now this distance means we subtract the larger distance. So if I say to you by, you say by is equal to bx, it is called distance bx plus distance xy. That's what it means. But I know my by is 14.576 is equal to distance bx, which is 6.91, plus distance xy, which we're finding that distance between the two criminals. So take that to the other side. So it will be 14.576 minus 6.910 is the distance xy. That is the distance between the criminals. So it will be 14.576 minus 6.910, and it's 7.666. So the distance there xy is equal to 7,666. So you can conclude now on that answer and say how far apart are the two criminals. You can say the two criminals are 7,666 apart. That's what it means. Don't forget the units is in meters apart. So you have to put it properly to say the two criminals are 7,666 meters apart. So that is the actual answer there. Alright, so it was a little bit of working. How many marks was this? This question was 5 marks, so it was good marks in a way. A little bit long, but if you've done the lessons, you will be able to follow up on that. Look at this question 5.4. It says given the function, so we're given this function y is equal to sin x minus 2 for 0 is less than or equal to x less than or equal to 108. Says draw the graph on its own system of axes on the graph paper. You see that? They want you to draw this graph. So for you to be able to draw this graph, what I always encourage, have your table of values like this. Alright. Have try to look for points that will be as many as possible. So, and your calculator will help you to draw these graphs. So what you do is you have your x and you have your y. So remember what you do. The calculator will assist you. Let me show you how I use the calculator. So I change to mode 3, and then here I say f of x. What I do is I say f of x, I do say sin alpha x, see how I put the x, close the bracket, minus 2. That's what I do say equal to, they say start from 0 until 180, 0 equal to, and say 180, say equal to, step, I always say choose the smallest step, which is 15. So it's either you take 15, 30, 60, like that. Then you choose for the numbers that are actually very simple. Now the numbers that are simpler here, 0 minus 2, you see that one? When x is 0, y is minus 2. Gonna take that one. And then when x is 15 is mixed up, minus 1,741, leave it. When x is 30, y is minus 1,5. So 30 here minus 1,5. So you continue again. 45 is got a long decimals, 60 long decimals, 75 long decimals. There is 90 is minus 1. So you've got 90 as minus 1. And you continue. 105, 120 is out, 135, 150 is minus 1,5. So you've got 150 minus 1,5, and then continue, and then 180, the last one is minus 2. So 180 is negative 2. Remember, they say start from 0 and in 180. So these are the values that were easier to have. When you've got these, they say draw a graph. So now what I'll do is I will plot a graph from this. So if I come here and, for example, just let me look at that, and I make my graph, and I think that is much smaller. I think this is much better. So let's say I want to plot my graph here, and remember I have to look at my values of x. X is positive only, 0 and the positive side. So which means when I'm plotting the values of x, it's only the positive, but the y values also I'm noticing that they are only negative, and it's from -1 to -2. So now when I'm plotting then my graph, I need to draw the graph in such a way that caters for that. So if I have it like this, because it's only negative, so this is my y, this is my x. So now remember, I'm moving in 15, so this is 15, that is 30, and then you've got 45, and 45 becomes your 90 there, and then I think it's 105, 15, 30. Actually, I jumped a lot here. It's 15, 30, 45 plus 15, so it's 45 plus 15, it's 60. You see I jumped a lot, so it's 60 there, 60, it's 75, and then 75 plus 15, so 60 plus 15 is 75 plus 15, it's 90, plus 15, 105 plus 15, 120 plus 15, 135. Yeah, so this is 90, 105, 120, 135, 150, 165, and I think it's 180. So this is what you are having on these. Quite a few. Remember, we're moving with 15 apart. Then the values of y, if this becomes -1, this can become -2, because the highest one is -2. So let's look at the points. When x is 0, y is -2. So I start with my point there, just to make the graph big. And then when x is 30, y is -1,5. 30, we have got -1,5 here. It's -1,5. And then 90 is -1. Come to 90, then you have a -1 there. And then 150 is -1,5. So 150 is -1,5 is going back there, and 180 is -2. So 180 is that part of -2 there. So now we have to draw the graph, and if you can see it carefully, this is how this graph is actually looking like. So you see that it is actually supposed to curve in a way like, okay, just make sure you are having yours as smooth as possible. You see, like that, it is supposed to curve nicely like that, but mine is now not curving well. But from here you need to curve it nicely. So this is the graph of f of x, and then the question says read from the graph the value of values of x. You can see that the value of values of x, of which y is equal to -3/2. Now remember, if you take a calculator and say what is -3/2, -3/2 equal to SD is -1,5. So you come here and say this is -1,5. So that is the value of y. So you come here and say y is equal to -1,5 is there. So you take your line and do that. And if they're saying read from the graph, so they are talking about that point there and that point there. If in your table of values will tell you of that -1,5, and -1,5 is that point, and minus 1 comma 5 is that point. So if they say read from the graph the values of x for which y is that, so you go to y, remember this is y is equal to minus 2 minus 1 comma 5. So the values of x, you can see that x here is equal to 30. That's why they say value. If you think it's one but there are more than one, there is also x is equal to 150. That's what they wanted there. Then you get your 2 marks. So guys, with that, you are now 16 marks rich in this exam. Now we are still continuing. So as I said, even here, you can see this was x is equal to 150. And this was x is equal to 30. This is where the line is cutting the graph there. Alright, now let us look at this question. This was now the last question. Question 6 was the last question in this exam. And in this particular question also it carried good marks, but question 6 mainly deals also with some formulas. For example, convert. This is 1 mark. If you can look at the mark allocation, it's 1 mark, and it says convert 7555 radians to degrees. So you go to your formulas and look at the formula that covers that part, and you'll see there is one, and it is this part, degrees and radians. You see 180 degrees is equal to pi. So you come here and say 180 degrees is equal to pi. So they want you to convert 7,555, then that you don't know is x, then you cross multiply. So you say x times pi, which is pi x, is equal to 180 times 7,555. This is called proportion. Now to remain with x, you divide by pi, then when you do that, x will be equal to radians now. So it is 180 times 7,555 divided by pi, and then you'll have 432,8696. Say shift, set up 6 and 3 decimal places is 432.87. So that's 432,870. This, remember to decrease, you put that to decrease. So that is what they needed there. That is how you convert that. Next one is 2 marks. It says the peripheral velocity of a wheel with a diameter of, okay, there is the diameter of 3/4 meters is 5 meters per second. So the units is meters and meters per second, which is the standard unit, so nothing to convert there. Say now determine the following: the number of revolutions completed per second. So you go to your formulas and look at the part which deals with number of revolutions. So if you look at the formulas here, and if you look carefully, there is revolutions per second and it is n, and there are 2 formulas that deals with n: angular velocity or the circumferential velocity. Now if you look back, the question says the peripheral velocity, and the word peripheral is the one for circumferential velocity. That's the same word. So which means here we're dealing with the formula under circumferential velocity, which is v is pi dn. So you come here and say for that formula, v is pi big D and n, which is revolutions per second. Now the question says calculate the number of revolutions. So we're looking for n, and we're given v, and v is 5 is equal to pi times our diameter is 3/4 and then times n. So you divide by pi, you divide there by pi times 3/4. Even this side is pi times 3/4. That will then cancel to find n. So my n will be equal to, in this case, it will be 5 over pi alpha, it's shift pi times 3 over 4. Alright, so when you get that, it's 2,122. See, calculate the number of revolutions. So it's 2,122 revolutions. So these are the revolutions. Remember, it's per second. If you look at the formula, it even tells you revolution per second, or R per S. That's what you can have. Now the next question says, if you can remove that part, let's leave the answer because sometimes it continues. Says here, we need the number of revolutions completed per minute. You see, it's now 1 mark. So this was revolutions per second. Now you can use proportion. 2,122 was 1 second. Now what about in this case, remember, if you're dealing with a minute, what about 60 seconds? Then you say it's x. 60 seconds, remember, it's a minute. Then you cross multiply again, x times 1, which is x is equal to 2,122 times 60. Then you will find now the revolutions, which means they must be more in a minute in this case. So it's 2,122 times 60, which is a minute, which is 127,32. So there is 127,32 revolutions in 60 seconds, which is in 1 minute. That's what they're saying. Alright, now having done that part, let's continue to look at question 6.3. Now question 6.3 say a sector is cut off from a circle with a diameter of 14 centimeters. So it's a sector. We're dealing with a sector. Says calculate the area of the sector in centimeters squared if it subtends an angle of that at the center of the circle. So we're dealing with a sector. Look at the formulas for the part that deals with the sector. And if you look carefully, we have a formula that deals with the sector and is that. And to deal with area, we are looking at that, which says area is 1 over 2 r squared theta. So you come here and say on 6.3, that 6.3 a is 1 over 2 r squared theta. That's the formula. And they've given us information. They've given us instead diameter is 14 centimeters. So you need to know that a radius is equal to diameter divided by 2. You divide the diameter by 2, which is 14 over 2. So the radius is 7 centimeters. So the angle there is 75 degrees again. So the theta must be in radians, which is 75 degrees. Do you see this question also was 4 marks? So the whole 4 marks was on you being able to do conversions. Now 75 degrees, you must convert it, remember, to radians, which said 180 degrees is equal to pi. What about 75 degrees? You say it's x. Cross multiply. So x times 180 is 180x is 75 pi. Divide by 180 to find how many radians are there in 75 degrees. So your x will be equal to, so you do that and say 75 pi over 180. Then it will give you 1,3089, which is 1,309. So it's 1,309. So these are radians because you have to convert. So now your area is now in the right format. It's 1 over 2 times the radius. Remember, it's half of that, which is 7 squared times theta, which is 1,309. Please don't use 75 degrees for theta like that. You must convert it because we're dealing with radians when we're dealing with circles. 1/2 times 7 squared times 1,309 and is 32,0705, which is 32,071. So it's 32,071. Now what are you dealing with? You are dealing with centimeters. They say calculate the area in square centimeters. So that will be the area of the sector. And that's why they gave that 4 marks. Alright. And then last but not least, you have been pocketing some marks and maybe you missed it there, maybe I missed it somewhere, but at the end of the day, this looks still good. Now let us look at 6.4, the last 4 marks, and it was out of 12 this section, and you can see we are towards the end there. It says calculate the length of the chord in a circle. It says the length of a chord in a circle is 6 centimeters. So it's a chord. We're dealing with a chord. That's important there. That's the key word there. In a circle is 6 centimeters, and the diameter of the circle is 9 centimeters. So we're still dealing with centimeters and centimeters there. Calculate the height of the minor segment and major segment of the circle. So it's 4 marks, the height of the minor and major segment. So what they're saying is, if I have a circle like this, alright, then this circle will divide it into parts like this, and there is a center of the circle. The center of the circle will have a diameter. So that diameter is 9 centimeters. Now this is the chord here at the top. Now they're saying the height of the chord, this distance here, is the small h, and then the other distance here is the big H. This is the height of the major segment and the height of the minor segment, small h and big H. So when they do that, they say calculate the height of the minor and major segment. Let's go to the formulas that deals with that. I think it's in the previous one. So now if I look at the second formula, if I look at the second formula page, and yes, this page, you can see they talk about that part. Yes, this is the segment of circles, and then they tell you the chord length is x. So here, if I come to the length of the chord is that x, and then the other thing is the height of the chord of the segment. Remember, this is minor. Diameter of the circle is d, and then they have this formula here. D is h plus x squared over 4h. So it is that d is equal to h plus x squared over 4h. So let me verify it again. So it's h plus x squared over 4h. So now let's look what we're given. It says calculate the height of the minor segment and the major segment. They gave us the diameter. It says it's 9 centimeters, is equal to, and then the chord, it says the length of a chord is 6. So we have got h plus, in this case where there is x squared, that's what we have got, 6 squared over 4h there. Remember, we're looking for the height of the minor and major segment. So when you have done that, to solve for h is actually something you have to do. Take the small h to the other side. You have 9 minus h is 6 squared is 36 over 4h. Now multiply by 4h this side, open the bracket, and also multiply by 4h. So what you have is 4h, 9 minus h, is equal to, you cancel there, you have 36. So you open this bracket, says 9 times 4 will be 9 times 4 is 36. So you've got 36h minus 4 times h, 4h times h is 4h squared minus 36 is equal to 0. Now I hope you're seeing what's happening there. If you write it properly, you will have minus 4h squared plus 36h minus 36 is equal to 0. You can see that this is now coming back to a quadratic formula, and if you divide by -4 on each and every one of them, you can simplify things much better. It becomes h squared, then 4 into 36 is -9h, 4 into 36 there is negative is positive 9 is equal to 0. So that's what you are having here. And for you to be able to solve, remember, this is similar to quadratic formula, which is a x squared plus bx plus c is equal to 0, such that you have the 1 there, the a here is 1, the b here is -9, you can see the h and x, and the c is positive 9. So the formula is x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. So you've got x is equal to minus 9 plus or minus square root of minus 9 squared minus 4. My a is 1 and my c is 9, and then it's over 2 and 1. So let's look at the values of x. The first one, if you solve it, minus bracket -9 plus, take the positive, plus square root of -9 squared minus 4, 1 and 9, right, all over 2 and 1. When you do that, take the first one, it's 7,854. So you've got 7,854, or the second one, x is equal to, you play back here, put a negative, press SD, is 1,1458, which is 1,146. So remember, we're dealing, the units that we're dealing with was centimeters, so you must maintain as centimeters. Now the question will come back and say, remember it says find the height of the minor here and major segment. So minor means the smaller value of x and major segment means the bigger value of x. So you must come here and conclude and say minor segment is equal to 1,146 centimeters, and then you say major segment is equal to 7,854 centimeters. So that's what they're saying here, to say this was 7,854, and this, the minor one here, it was 1,146. That's basically what they mean. So this then, in a way, if I look at this, it concludes our lesson here. And remember, this question was out of 100 marks. So yes, indeed, I went. First time up to the end and gave you some suggested solutions of this mathematics N2 that was written in April or last year, in mid last year, and I hope the solutions were of help to you. But as I said, there can be some errors that were picked up across, and if there are some, you can always bring in some suggestions or some better methods of understanding those. But remember, if you see me doing them slow, it's because I am dealing with those who are already struggling with their math. I was an underdog, so I also care for the underdogs. I hope this is of benefit to you. If you're benefiting, remember to like our channel and subscribe, as well as forward or share this with other friends and colleagues, and trust me, they will also benefit. Again, remember, I've got a lot of resources. If you want me to teach you and mentor you on your mathematics, remember to check our website, and you will find everything that you need so that you can join our online classes. We have come to the end of our lesson. Thank you.